will be a star freelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Let's look at the syllabus of this course, that is the course content. It is very good you understand the entire structure of the course so that you know what you are enrolling for. As you can see, we started it very simple from the beginning, looking at what? The difference between SQL, MySQL, and DBMS and database versus data. Then we look at why we are using MySQL in this course to study SQL. In section 2, we look at installing MySQL in macOS and in Windows. We also look at how to troubleshoot possible error that might occur. In section 3, we look at what? Database resources for this course. If you check here, we have the Notwin database, we have the research database, we have the camera database, we also have the cash shop database, and other resources you might need will be uploaded according to the session. Section 4, we look at what? How to use select statements. In brief, just to understand it for absolute beginners. The next one is database. We look at database versus table for layman from the very basic. Then we move to creating a database. We look at various challenges. You can see there are many challenges in this session. We use different possible scenarios that you might meet in real world. Okay? Then we move to create table. The next one was data types, which is very important. From there, we go into how to insert data into your table. Different scenarios. From there, we move to type of keys. Candidate key, surrogate key, primary key, alternative key, and foreign key. From there, we went deeper into primary and foreign keys and how to create them, how to use them, all the possible scenario you will meet in real world. We revisit back to select statement. Here is just brief because you need this to be able to work on this database, to work on create table, to work on data types. The reason why we first of all introduce it. Now we have to go into select statement deeper. We see different challenges and solutions, how to vary it, how to use it. We saw alliances, use it as a lot of information. Okay. We now went to concat function because we need this concat function for the next session. Okay. We saw different scenario and different challenges. Then we went further to look at order by. Okay. You see other bar with different challenges and what we meet in real world. We also look at limit clause. See, we look at different challenges on limit clause. We also look at other bar and random function in great detail. We also look at comment. Then we look at where clause. Where clause is one of the pillar of MySQL. So we dig deeper with a lot of scenarios, a lot of challenges. You can see them. They are just there. A lot of challenges. Once you understand it, the next thing is index. Index is another very important tool in SQL. So we look at it also in great detail. Then we also look at wildcard. Wildcard is also very important. You can see we look at a lot of challenges. Then we went for update statement and replace function. Okay. Very important on how to replace and how to update your table. This one is select distinct statement. Okay. We separated it from select so that you understand it in great detail. Okay. Then we went for format function. Then we went for group by. Group by is also very, very important. You must understand this. You can't compromise not to understand group by. So that's why we dig deeper into group by. From there, we started join. If you don't know join, then you don't know anything in SQL. This is the introduction to join, made easy. We make sure that you understand it in simple language. From there, we went deeper into join. Okay. After that, we now look at on versus where in join. Okay. On versus using in join. Okay. We look at the difference because this is very confusing for some people. Okay. We look at the difference on how to use them to manipulate your result. We now look deeper into join with a lot of challenges and solutions. As you can see in this place, this one we go further to reinforce what you study in the previous sessions. After that, we now look at join for one table join, that is step join, 2, 3, 4, 5, 6 to 10 tables. Okay. You're going to learn, for instance, the summary of the whole thing. Here we look at one table join. I want to tell about this course is that once we finish, we also put the code for you, the query which you can use to test on your own. Okay, look at this one, 2 table join. We look at 3 table joins. We look at 4 table joins, 5 table joins, 6 table joins, 7 table joins, 8 table joins, 9 table joins, 10 table joins. Once you finish the join, you can do 30 table join, 100 table join. Any amount of table you have in your system, you can join them together once you complete this section. From there, we went to offset and limit. Okay, offset and limit, another very important tool. Okay, then we move further to case function. So you can see here, we also look at cast function. You can see how detailed it is with a lot of challenges and solutions. Then we look at nested and correlated subquery. This is also very confusing. We make sure that we did a lot of justice to it in this place. After you finish this, nested and correlated subquery will be a piece of cake. Then we look at subqueries and exist. Okay, this exist as subquery is also very confusing. You need to look at it because we did a lot of justice to it here too. We have done nested and correlated here. We went further again because what we learn in this place will help you further to dig deeper into it here. Then we look at string functions. You can see all the string functions like repeat, space, replace, reverse, left, right, rpad, headpad, position, and so on and so forth. All these are string functions. Then we look at session in MySQL. Then we move to table locking. Okay, from there we look at transaction. Transaction is another very important topic you must take serious. Then we look at view. View is very important. We look at it in great details. Okay, in great detail with a lot of challenges and solutions. Then we look at stop procedure. Can see stop procedure here? We look at stop procedure. Stop procedure is another confusing topic. We make sure that what we did justice to it. Once you finish this section on stop procedure becomes what? An elementary topic for you. We also did user defined function. You can see, or we did a lot of challenges and solutions. Trigger is also very important. See, we did a lot of scenarios, real world scenarios, so that after you finish trigger in this course, whenever you see trigger, it will be a piece of cake for you. Okay, after we have finished all that, we now went to this data set called the reset data set. Okay, we use different scenarios to look at joins, subqueries, nested subquery. Then we look at cache shop data set. The same thing we did. We look at a lot of challenges. We see a lot of scenario under this data set. Then we also did camera supply data set. Okay, using different challenges and solutions to understand deeper different kinds of queries in MySQL. Under this section, we mix everything together. I want to see if you can remember different things you have done in this course. Okay, see another task, this another task. Look at this one, so many of them, different kinds of questions. You will have access to the codes or to the query we use in the course. Different kinds of tasks. Now we want to move to task 15. There's something you need to know before task 15. The reason why this was done again. Okay, the reason for this section is for you to be able to understand what we are going to do in this place. Okay, this one too, this one too. Then this section requires this. Okay, you have to pause to learn all this before you can now understand this particular one on task 18. From there, we went further to look at MySQL Python. In case you want to query database from Python, you need to know how to connect them together and how to query MySQL using Python programming language. So these sessions covers all that. Okay, from there we look at business intelligence and analytics with Tableau and SQL. Okay, here you will learn how to install Tableau, what is Tableau, business intelligence. We also know about the important things you need to know to go deeper into Tableau. You also know how to connect MySQL to Tableau. We also learn how to visualize some databases we have used in this course, like this one, visualizing cache shop data set. Then finally, we look at an important challenge that will reinforce everything we have done on that Tableau. When you have finished this course, I promise you be able to deal with complex queries. I look forward to receiving you on board. Thank you.
This is Mary. She is SQL developer.
And Mary could be a data analyst. She could be a business analyst. The question says that Mary is about to go on leave. And in this company, they sell cars. The sales manager doesn't know anything about SQL. So a manager told her to develop a simple SQL query for the sales manager to be able to query the database while she's away to get the price of cars in euro, pounds, and yuan. Okay? Let's see what we have in the database. We have two tables, cars table and manufacturers table. Very simple, right? Now, let's check what is in car table. The car table contains names of different cars, their prices in USD, and the manufacturer ID. Okay? Let's also check what's in this table, manufacturers table, names of the manufacturers of these cars. This is the SQL Mary developed for the sales manager. How does it work? This is what SQL query that will convert the correct prices in USD to euro, pounds, and yuan. Okay? At the end of this course, this kind of query will be a piece of cake for you. It will not be difficult at all. This is a very simple query. I'm going to teach you everything line by line, precept by precept. Let's first of all run this one I selected. When I run, it's showing me the name of the manufacturers, the car names, their prices in USD, as you can see, price in USD, price in euro, price in pounds, price in pound sterling, the price in what? In yuan. You will agree with me that the sales manager shouldn't be doing this all the time. That is the purpose of this view. All this will be explained. This is one of the several queries we use in this lecture. Let's now run this entire query. I haven't done that. Let's now check again before we have these tables. Let's check again. The price list is not included as what? As a table. That's what we created here. This one, we use it to wrap this one. Everything you saw was placed inside this place to create a fresh table for the manager to use. That is the reason why we have this one at the third table, which was not there before. Now let's check what is here in this price list. This is what the manager will be doing from now on. While Mary is away, the manager will simply be saying select everything from price list. Let's run this. Look at it. So Mary did this, everything here. Now it's away. From now on, the manager will simply come to this place and type this. Very easy to get this result. All these are many SQL complex query we are going to what? Demystify in this lecture. At the end of this course, you will be able to write this kind of queries with ease. In this course, we have a lot of tricky exercises like this. We want to have the names of customer who placed order in 1996. This could be end of year report, or you are doing some report on a particular year. Okay, along with their total order, that is sum of unit price multiplied by quantity, and the following comments. We want this comment along with this report. Order below 1,000 should read very low order. Order between 1,000 or 5,000 should read low order. Order between 5,001 and 10,000 should read medium order. Order between 10,001 and 15,000 should read high order. Order above 15,000 should read very high order. It depends on what they are selling. So this is the way they want to have the report. Okay. And you are the data analyst. You are asked to do this. This is the type of SQL query we use for this type of reports. Although it looks complex, but it's very simple. At the end of this call, this will be a piece of cake for you to write. Okay, let's go ahead now and run this query. If I run this, look at the report. The name of the customers on this column. This is the total order placed. For this one, very low. This is low, very low. This is high, and so on and so forth. So at the end of this course, this should be very simple for you to write by yourself. Write a query to get employees' territories, employees' first names, customers' names, names of products, categories of products, suppliers' names. You are the data analyst in this company and you are asked to do this. This is a query we use for this type of challenge. It has so many tables, so many joins. Altogether, we have 8 tables to join together to get this information. I'm going to explain all these queries, the reason why we write the query like this, step by step, precept by precept. We're going to start from absolute beginner level to advanced level. At the end of this course, this kind of queries will be easy for you to write. Let's see. This is it. If we run this now, we have all this information cut across different tables. If we show tables, you see we have many tables in this database. So this information are cut across different tables, such as employee, orders, order details, products, and so on and so forth. We are going to look at one table join, that is self join, 2 tables, 3 tables, 4 tables, 5, 6 tables, 7 tables, 8 tables, 9 tables, and 10 table joins in this course. There are several things that are covered in this course. I will implore you not to miss any of this class. So these are just sample for you to see what we did in this course. There are several things we cover in this course. You cannot afford to miss any of them. Without any further ado, let's jump in and start. Hi, what map is this? This is USA map. What about this? This is the UK map. US map and the UK map. Which language do they speak? They speak what? English. Let's check something, then we'll come back to this place. Look at this. SQL. It stands for what? Structured Query Language. Remember, it's just what? A language. SQL enables you to design, access, manage, and manipulate databases. Remember, it's a language that enables you to design, access, manage, and manipulate databases. This language does not change because it is what? A language. English is a language that enables you to communicate with the Americans or the British. Remember, it's a language and what? It does not change. So if it's all about database, if it's language we speak inside database, just the way we speak English in USA or in the UK, if it's a language we use to design, we use to access, we use to manage, we use to manipulate databases, what is there for databases? Database is a collection of data. Collection of what? Data. Organized. Remember, if the data is not organized, we are not talking about database. Organized in a manner that allows what? Access, retrieval, and use of that data. If you can't access it, you can't call it what? Database. If you can't retrieve it, you can't call it what? A database. If you can't use that data, you can't call it what? Database. Remember, it's about data. That means what we are talking about is based on data. Okay, and the language you use to do all these things, to access, to retrieve, and to use is called what? SQL. Structured Query Language. Then what's about this data we are talking about? When you say a collection of data, organized, okay, organized. Okay, in a simple word, data can be what? Facts. Fact about what? Related to any object in consideration. If you are the object in consideration, what are the facts about you? You have a name, you have email, you have address, and so on and so forth. These are what? Data. What about your height? What about your weight? And other things that are what? Related to you. What about pictures you take? Pictures. What about image, files, PDF files, and so on and so forth? Where you organize this about many people and store them in a place, you are not talking about what? Database. That's what this one now we are showing you here. This about student what? Name and age. Only this what? Table. This about the subject and the teachers that are teaching them, organized in a table. This one is talking about what? The relationship between what? These two tables. So that we can be able to what? Use them accordingly. Understand? But what do you use to do all these things? If you want to create this one, you want to create this one, you want to create this one, you want to impute this, you want to delete, for instance, you want to change this one from C++ to Java, for instance. What do you use? You want to delete the entire table, you want to put a new one, you want to put another row. We use what? A language you all call SQL, just a language. But remember, this is a language, but USA is not what? A language. They are what? People. Okay? And if these people want to communicate, they use this language. But USA is not English, but English is their language. The same thing with what? The UK. Having said that, where do we use this language? That brings us to Database Management System, DBMS. DBMS, number one, you should know, is about software. About what? Software. What are these software all about? This software allow a user to store and to retrieve data from what? Database. This is a database. This is the user. The user want to talk to the database, which we have seen. There's something that stands between you and the database. That's called what? The DBMS. DBMS is not the database, and database is not the DBMS. And database is not SQL. SQL is not database. SQL is not DBMS. DBMS is not what? SQL. SQL is a language you will use through DBMS to access what? Database. Are you getting it? So DBMS is a software. Helps to manage relational database using what? SQL. Is the language. This guy will speak through DBMS to what? To do whatever I want to do with this what? Database. Because it's a software, it is frequently what? Updated. Because what? It is a software. We have different types. We used to talk to what? Database using SQL. These are DBMS. DBMS. They are what? Softwares. These are Microsoft Office Access, Microsoft SQL Server, Postgres SQL, Sybase SQLite, IBM DB2, and MySQL, and many other ones out there. If there are so many, why are we now using MySQL? Before I will explain that to you, the next thing you ask me now, which language does this one speak? This one, this one, this one, this one. All of them what speak what? SQL. But what is the difference between SQL use in Oracle and the SQL use in MySQL? The one used in what? Postgres SQL. The one used in SQLite. The same but little what difference. This one take me back to what? USA and United Kingdom. If you're in this country, if you write somebody here, if you write on the paper, I'll say, please, I need my money. Give me what? A check. This is strange. It expects you to write what? Check. But here, this what? Check. But the same thing. In the UK, the same thing, the same thing. You get it? Here, if you are here, they expect you to write center. Here, they expect you to write what? Center. Same thing, but different what? Spelling. The same thing. Okay? Americas. America goes for what? Vacation. The British, they go for what? All. They say all or holidays. Same thing, but same communication, but different implementation of this language called English. You agree with me? In US, I will simply say what? Lend MySQL from Mr. Don. Here you say what? Land MySQL from Mr. Don. The same thing, but different implementation. But at the end of the day, what is achieved here? Communication what? Is achieved. The same thing goes to this place. Here, the same SQL, the same language they are all speaking. When you are here, same language. But when you are here, the way you will use this language, there might be slight difference. The way you will use this one, slight difference. Slight difference. Slight difference. But at the end of the day, something is achieved. What is achieved? Database management. Hope you understand the difference now. We have a language. We have something we want to access. Data. Now, organize, call what? Database. But to access them, we need to what? Speak this language through what we call what? DBMS. It will help us to communicate. So I am here. What I now have now is a screen. I'm using this one as a language I've learned to walk through DBMS. Now, MySQL to talk to this guy. Another person might decide to what? Do the same thing through this guy. Same thing through this guy. But why are we choosing MySQL in this course? That is the next thing we need to investigate. Thank you for your attention and for viewing. It's an open source software for database management. Although we have what? An enterprise version. Number two, it is free because it's open source. It's reliable. It's mature. And it's also what? The most popular among many. Most organizations, in one way or the other, use what? MySQL. So you hardly see one of the best or most popular company today that is not using what? MySQL. For instance, Facebook, Twitter, YouTube, LinkedIn, all of them, in one way or the other, have used what? MySQL. Now, let's see some graphical survey of this same thing we are talking about. As I said, we have many DBMS, but we are using what? MySQL. Why? Because it's the most popular among all of them. Is the what? Most popular among many. You can see the chart. This from where? From here. You can Google by yourself and see. Why is it so popular? Because one, it is an open source what? Software. Though it has what? An enterprise what? Edition. SQL has many powerful features. So MySQL remains the number one most used database system in the world. Oracle sometimes shoot up ahead of MySQL. It depends on where you are doing what? The survey. What's most popular databases? See? Oracle. The difference is very small. Then we have what? MySQL. But what you should know, this is paid. You need what? Dollars to pay for it. Okay? You need money. You need to have what? Enough money to use this one. This is open source. Once you master this, you are in great advantage. Most of these ones will not be difficult for you to what? Understand. Most of them. So it's good to start with MySQL because you don't need money to start it. And the language is matured, it's reliable. And the more you know about it, the more you have a lot of opportunity. That is the reason why I choose MySQL to study what? SQL in this course. MySQL is not the only open source. Look at other open source and see their popularity. This is what? Among the open source, MySQL is still what? 31%. The nearest is PostgreSQL, 13.4. PostgreSQL, followed by MongoDB. You see that if you understand MySQL, in short, you are in great advantage in your career and in your implementation. SQL is a big advantage. Understanding it through MySQL is a super advantage. Hope this information is useful to you. Thank you for viewing. Hi, I want us to look at how to install MySQL in your Mac OS. The first thing you need to do, you Google MySQL. This MySQL, you click on it. Click download. There you go straight to MySQL Community GL download. The next thing you do is to look for MySQL Community Server. You choose your operating system here. My operating system is Mac OS. Then you download the latest version. You click here. Click on no thanks, just start my download. You click. Once you click, it start downloading. But I have to cancel this because I've already downloaded MySQL. You go to, because I've already downloaded it, so I'll just come here. This is the download I already done, so just to double click. I start the installation process. It's opening the DMG file now. So I double click this. But while it's going on, let me just show you something. If you go to System Preference, click on System Preference, you will see that there's nothing like MySQL here. It's supposed to be somewhere here, but I don't have anything MySQL here. So if you open your Mac, you don't see anything here related to MySQL, you know it's not your system yet. It's telling me that I can't do this because it was downloaded outside App Store. So I have to go to System Preference, go to Security and Privacy, open anyway to allow it to open. It's asking me if I'm sure. I say yes, I'm sure. I open. Now it's about to install. Continue. I want to install here. Install for user of this computer. It's asking me for my password. Your system password. You put your own password. Say use strong password encryption. So it's asking you to put your old password, the one you will use for MySQL. So it's asking me for my system password now, my user. Let's open a terminal. Open a terminal. Okay, the next thing now is to check where we are, because we need to be in our user directory, pwd, showing that I'm in my user directory. So I need to check for the bash file. AL, say list AL to see all your file, but I want to see the bash one. Bash. The bash file. So this one I'm looking for. This particular one. To see if I already have it. Luckily I have it. If you don't have it, you can say create it. Assuming you don't have it, all you need to do to create it is touch.bash _ profile. If I click enter now, it will create it for me. But I already have it. I don't need to create it twice. Let me clear this. To open, is it open? .bash _ profile. It has opened it for me now. When you open it for me now, I want to put the path to my SQL. To not put the path, how to locate my SQL in your system. You need to help your system to know the location of my SQL. This is the path to it. I will drop this for you below. Once you do this, you close. You open your terminal again now to see. So how do you access my SQL? Just tap my SQL. Put your password, the one you put just now. When you were creating this. Once you put your password, this will come out. To also double check that your SQL is installed, go to system preference. See, this one was not here before. Once you see this, it means that what? My SQL is running. You know, before we have only this here, but now we have my SQL now, meaning it is now installed in your computer. Thank you. I believe this was helpful. You come here, you click connection. It's telling you cannot connect to database server. Okay, let's try another thing. Let me say I want to do new connection. You put any name here. Let's say just put MySQL connect. After you put MySQL connect, there you come here now, you put the password of your server, which is whatever you use while you were installing in your Mac or your computer. Then let me test it. See what it's saying. It says this failed to connect to my SQL at this. Failed to connect at this. Look at it. Failed to connect. And this is the error it's giving to you. Authentication plugin. So how do we troubleshoot it? I want to show you how to troubleshoot this. The first thing you need to do, what do you do about this? If you want to connect this, the first thing you need to do, what to correct this, is to go straight to system preference. When you go to system preference, you click on this, MySQL, double click. Try to initialize the database, because this is the first time you are trying to connect to the database. You put your password there, the same password you used to install your MySQL. They use legacy password encryption. Don't choose this one, choose this one. You click OK. Now it's working. Then you put your password, your system password. So it's still working now, trying to initialize the database. This is where the error was coming from. So I will start now. Start my. After doing that, you start now. You see, they have changed. The color have changed. Once you have done this, you close that, then you try to connect again. Now it's connecting. See, it's connecting now. So it has connected. See, it has connected now. I hope this was informative. Thank you for viewing. To install MySQL Server and Workbench, you first of all go to Google, then you search for download MySQL. Then you click the first one, MySQL installer. Pick the one with higher megabyte. Two of them look the same, but this one is 24.5, while this one is what? 247.6 megabyte. So you download this one. Okay, then you click download. It will open this one for you. Say no thanks, just start my download, no need to log in. It's not downloading now. Then you go to your download where you download it in your system and double click. The installer is be started. Then you choose custom among the options. It will give you this one. You go to the first one, MySQL Server. You expand the next one. You expand again. You move this one to the next pane. Then you look for the workbench. Expand on the workbench, other applications. You move it to the right again. You click next. Then it's giving you one. You say yes. These two will start what? Installing now. The server and the workbench. Once it finishes, then you click next. Next again. Leave it on the standalone MySQL Server. Classic MySQL replication. The first option. You click next. All these options, don't change anything. The first option is okay. Development computer. You click next. For the authentication, let's use the first option. Then choose a strong password, which you will use for your root password. You check. It accept. Or check this one. Start MySQL Server as system starter or check it. Next. Execute. Wait for everything to what? To configure. Because we are applying the configuration at this time. That is all. You click next. Finish. Your workbench and servers are installed. Look at it. You double click the local instance MySQL. The password you choose for your root while you are installing MySQL, you have to put it here now. Once you put it, it should take you to workbench work environment. Hope you understand the process. For the case you can't connect, let's check the next step to correct any error of connection. Thank you for viewing. You successfully installed MySQL Workbench at MySQL Server in your Windows, but you click to connect, it's not connecting. How do you solve this problem? You see, you are trying to connect, it's not connecting. With all this error, you see, no connection established, could not connect, server may not be running. You see here, unable to connect. So how do you solve this type of problem? Or coming here, you found stopped. Still the same. Same. There is a way out. Let's see the way out now. You should kindly come here and search for services. Okay. You see, it opens here for you. Click on ActiveX Installer. Okay. Then it will give you MySQL. which you have to click. You see start, or you right click as a start. So it's starting now for the first time. So with this, it's starting the process now. See, it has started. It's running. You can either stop, you pause, or you restart because it has started. See now? And you can see that this shows what? It has started running. With this, it is running now. And this one is now on. The message that was here had disappeared. This one, instead of no connection, is still no object selected. The other one I was here had disappeared too. It means now what? You are ready to run. You are ready to go into Workbench and start working with MySQL. Look at it. This is my SQL environment. Congratulations for successfully installing MySQL. Thank you for viewing. To practice along, you need the resources. Where are they located? They are located what? In section 3. Database resource for this course. That is all these ones. Not in database set, research, camera, catch-up. How do you use them? You simply click and download. For instance, if I want to use NotTwin dataset, I click on it. It says what? Download. All you have to do now is to open this file, copy and paste into your Workbench. I can double click on this. It will open here automatically. The next thing to do, very simple, just click and run. See? Accepted. So if I check for this show databases, find out what? NotTwin this here now. Just copy and paste. Let's say show tables. You see? They are all here. For instance, if I want to check the employees table, see, these are all the employees table. So any of the database you want, just click on it, download, copy and paste, or you open, automatically can open here, or you just simply copy and paste. Hope you understand this. That is all. If there's another data set in this course that is not here, it will be attached in that particular session. So don't worry at all. Everything is well planned. Hope this is clear. Thank you for viewing. A friend of yours who has been into social works wants to switch to computer science. Someone had advised him to start with SQL as he will need it as a base for data analysis, which is his interest. He has just started and has been trying to understand the real meaning of select. He came to you for explanation. Please explain. The best way to understand anything in life is through question and answer. If you ask quality question, you have quality answers. What you cannot put into question, to understand it most of the time, is difficult. In the process of trying to answer the question, you will definitely understand it. The first thing I want you to put in your mind is about result set or result table. Don't look at what I want to do first. Just assume you don't know. You see all this? They are actually in the database. And the name of this table is called employee table. And if you want to see other table, you can say show tables. These are the other tables in my database. Each of them have rows and columns, just like the way this one has. All these rows, these are rows. Each of these ones are row. Like number 3 is a row. Number 5 is a row, just like that. There are rows left to right. These are rows, rows, just like this. These are rows, or this one. Y up down is called what? Columns. These are columns, columns. And this is the name of this column: employee ID, last name, first name, title, title of birthday. Okay, and you can see that they contain data of what? Of employee that are employed in this company. Okay, so if these ones, their house, where they are living, where they sleep, is what? A table, this table. Okay, and the table lives inside what? The database. What I'm saying is this: if this is a house, and you call this house a table, what lives here are columns, rows, and information lives inside what? These columns are rows. But this table, which is a house, is located in an estate, for instance. Okay, let's say the name of this estate is Peace Estate. Okay, Peace Estate. And there are many houses here. That is, there are many tables here. I'm using this illustration now. These are many what? So many houses here. All these houses, which are tables, live inside this estate. And this estate now is the database. Okay? So now, if you want to take anything from any of this table, which is the houses where your data are living, if you want to take anything from them, you use select. For instance, now, if this table might be the employee table, I want to select all the rows or columns. We use select asterisk. Asterisk is to pick everything, both row or columns in what? Both rows and columns in a table. So you see, they are living here, but this thing you are seeing here, this result you are seeing here now, this one is called what? The result set. This one is the result set. This is not actually the database, or this is not the table. It's for your view, for you to see, for your eyes to see. Okay, this is called what? Result set, or you call it what? Result table. Okay, so this select has ability to pick something from these tables. Okay, or the table I just showed you, select has the power to pick anything from them. Okay, if you want to select, you want to pick, you want to take something from there. Remember when I say I want to see, for instance, I want to see all the tables. What did I do? I use show. Okay, I did not use select. Okay, show table, because if I want to interact with the database, I say show, describe. So with my show, I can talk to the database. Remember, the database is where all tables are living. So if I want to interact with the database, I'm using the word show. But if I want to interact with tables, say I want to see things inside the table, for instance, I want to see, therefore I will use the word select. But if I want to see things in database, I can use show tables, show this, show that. Okay. Now, I will say that this select is not only for things that are in the database. No, it can also do things for you that are not in the database, which can be solved by SQL, but the result will be returned to you on your what? On your result set. Let me show you what I'm saying. For instance, I can say select 1 + 1 is 2. This one is not in any table. This is just calculation done by MySQL, and it is returned to you. Where is this place now? Here. What would you call here now? This is called what? The result set. Result set or result table. This is not what? The table that lives inside the database. And if I remove this one now, for instance, as I remove this one now, this has disappeared. If I say, okay, select now, select, I say hello. The first one, the two I had, it had disappeared. You cannot find the 2 anywhere in the database. You can never see that 2. It's not logged in the database. It was only displayed for us. It's like this place, like your television. This place, this result set, this table is like your TV. Just to see something, and if you switch to another channel, another thing will be displayed to you. And that thing you just seen is not saved anywhere. That's why I will say, okay, select can be used to select things from the database. It can also help you to generate artificial columns. For instance, I can say, for instance, I want to see the first name. Remember, first name is a column that exists where is a column that exists in employee table. Okay, I can say select this first name, that's a column from employees. Okay, it will give it to me because this actually lives inside what? Inside employee table. It lives there. It stays there, this column. But there's a column that is not staying here. I can also say, okay, I also want you to give me along something like great person, great employee. This great employee does not live inside the database. It's artificial. I want to get an artificial columns to flow along with this guy. Okay, let's see now. See? Now, this is artificial. This is from what? The table employee. This one, if I remove this, all of them will disappear, right? But this one still stay in the table. It's not changing anything. That I put this one here now doesn't mean that what? It has changed anything. This great employee you are seeing here is not in this table. You will never find it in this table. It's just here for you to see on the result set. Remember I said result what set? This result set. For your own, look at it. They call it result grid here. Result grid. Some other person call it what? Result set. Just for you to see. For you, it's like your board, your working board, or your display board. For this to display for you. So here is like the output of your engine room. So if I come here and I say, okay, I also want you to put for me along 8 multiplied by 10. You see, it's giving me 80 for all of them. This one too is artificial for me. This is artificial. This is the only real column. You see what select can do? Select can be used to do a lot of mathematics. You don't need to say select from any table. You can do it here as long as what? You know what you are doing. I can for instance say 4 multiplied by 4. It gives it to me. I can say, okay, 20 divided by 10 gives me the answer. I can say, for instance, something like this. What is he using? It's using what? BODMAS. BODMAS, we first of all deal with what is in the bracket first before working on this. 4 minus 1, we give you 3. 3 times 3, we give you 9. Remember, this one is not in the database. This is just what you are using. You are using this place now as a calculator. And it's giving you the answer where? In your result grid. Your result grid. Doesn't mean that this 9 is not in your database or it's in your table. No. This is what select can do. Okay? So select can help you to select everything in the database. So this is the work of select. It's like immediately after select, whatever you put here now, you can put as many things as you want, as long as it's related to tables. Know that with select, you can select everything from a table. That is everything now you are selecting. You can also select specific columns, like I can select this, I can select this. For this, I'm interested in this date, I'm interested in employee what? ID. Just say select employee ID, and aside that also select other date. Please know that this is not case sensitive. You can put anything here. If I put small letter here now, I can even make this one capital letter. It will not penalize me. See, it's giving me what? The employee ID, also giving me what? Other date. I use other standard is the way I type it here. That is the way it's showing it to me as a title. If I change this one to E now, and this one capital M, that is the way it will display them for me here. So the way I want to see them in the result grid or result set, that is the way I should type it here. But it's not going to penalize me. But if I miss any of this, error will come out. There's error now. It's not allowed. There's something missing. But as long as you are perfect. Whether capital letter or small letter, you are okay. But if the table, you are referring to a table, no need to put quotation mark. But assume that this one, for instance, is not in the table. I want to put on like my name, Donatus, for instance. Donatus is not in this table. So if I do this, I will have what? I will have error. I have error. Select Donatus. This is not in the system. So because this one is not in the system, it means that what is, I'm not referring to what, to a column, because this guy is meant to select column from tables, right? Because I've said from this table. That's the reason why it's giving me this error. Assume I did not put this one up from anywhere. Look at it. It's still giving me this error, right? Because this one is a string. This one is a string. It's not a name of anything. Now it's giving me exactly. If you know that what you are putting here is not the name of a column, you have to put it what? Inside single quote or double quote. But what about integer and other data type like 67? Put 67 here and give me this one. Give me this one as the other date, 67. But if I put a string, I must be able to put what? Quotes. Hope you understand this. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
In a layman's way, explain the difference between a database and a table. The first thing is to understand the meaning of database and table in a layman's way. You can see a lot of definition out there. You can Google, no problem. But in a layman's way, what is the difference between a table and a database? If this is a company and they want to have information about their employee stored in a particular place, let's just use 2 employees as instance. Assume this Tony Brown and this guy is Andrew Tim. This is their name. Let's call this one full name. Let's just say the next one is phone number 0804 whatever. Okay, assume this is their numbers. This is what? Data. If you want to use MySQL to keep this information, you have to input them into a table. That has what? Columns and rows. But this table needs to live in a place. And the house it stays, that's a layman's way. The house the table will stay is called what? The database. What it means is that you agree with me, not one person that lives in a house. We have many people that can live in a house. So in this house, call company database. We can have information about employee. We can have information about the customers in another table. Information about sales. See, we can have many information stored in the form of this table, which will what? Keep here. Okay? That is the difference. This is the first place you put your data, direct contact with, but the table lives or stays in a database. So it's like you now, your name is James. Okay? You live in the house. You are the table. Your house is the database. And you agree with me that there are many people that lives in your house. Okay? The same thing with what? With table and what? And database. I would say that the next thing we're going to do now is to know or understand how to create a database. That is the next thing we're going to look at now, how to create a database. Why do we need to do that? Because you need to build a house first. Before what? You live in the house. So we need to have a database ready before we can now what? Put tables that will live in the database. That's what we are going to do next. You are new to SQL. Your supervisor asks you to create a new database with the name shop. This is for us to understand how to create a database. To do that, you simply say create database shop. Then you enter. The database will be what? Created. Let's move to the next level. You succeeded in creating the shop database. If the shop database was already in the system, you would have seen an error like, you can't create database shop. Database exists. To avoid such occurrence, what would you do differently if you are asked to create another database called estate? What you will do differently is, instead of say create database shop, okay, let's actually see the type of error it will give us if we are trying to create the database now that it's already in the system. You see what I say? Can't create database, shop database exists. To avoid such occurrence, what you do, you simply say, if not exists, this should be included. Before I create the estate database, let me put this one in now. Did it do anything? You just say what? Give us this sign that what? It cannot be created. Simply say, if not exist, then you put estate. So, create database, if not exist, estate. So, it's created now. Let's move to the next stage. How do you check for the existing databases? You have one database, 2, 3. How do you check which one and which one is in the system? To do that, you simply say show databases. You just enter. These are all the databases in my system as at now. This is the one you created, and this. Okay. This was the first one we created, and this second one. So to check for existing database, you simply say show databases. Among the existing databases, your supervisor asks you to delete the estate database. Just say drop. You say database. You have to tell the system that it's database you want to drop, because we also use this one to drop others like function, procedure, which you are going to see all in this course. And we can also use it to delete table. So you have to tell the system that drop. What are you dropping this time? Is it table? Is it procedure? Is it function? I want to drop what? Estate. I want to drop what? Estate database. So what I'm dropping is database that is called estate. Affected. Now, if I go back to see show databases, let's see if we're going to have the estate database. Can see it has been deleted. Hope you understand this. Let's move straight to the next step. You are ready to start working on your first project, and you are required to work with the shop database. How would you select it? So to select a database, you use the word use. Use. I will say use shop. If I say use shop now, it means I am now in shop database. Anything I will do from now on, I will be doing it inside shop. Okay? Perfect. Look at this. If you were here before, when you open the system, nothing was done. And there are many databases in this system. For instance, assume we have many databases. I'm doing it like this, looking at database as a house where you will store your what? Your tables. This is shop database. Assume that this one is not twin database. Okay. They say this one is cash shop. Many database. Okay. Now you are outside all the database. You want to work. You have to select the particular database you want to use. This use means I want to use this one. If I use this one, and that means I am entering inside to start working. You have to enter inside here. You start working. So anything you do now, once you have done this, you'll be working inside here. If you create table, it will be here, not here, not here. Anything you do is here. Just know that. Okay, I'm teaching you as like a beginner. Okay, you have to use the particular database. It's normal. You have many tools, your toolbox. If you want to use the spanner, you pick it to use. If you want to use the screwdriver, you use it. If you want to use the chisel, you use it. If you want to use the hammer, you use it. You cannot use two at the same time. You have to select the particular one you want to use. That's why you use this word. Use the name, you select the name. Hope you understand this step. How to check for the current database in use. If you want to know the current database that is running, you select database. If you run it, it's telling us we are using what? Shop database. For instance, if I change the database to something like Northwind and I run again, tells us what? We are now using Northwind database. Hope you understand this. Thank you for viewing. Why do you need a table in SQL and how would you create one? Look at this. This information and this information, which one do you think will be easy to manage? Not actually you can manage them. It depends on the type of database you are using. Okay? But in SQL, we need a table because database is about data management. What is management about data? One, insert new data. Two, you should be able to delete any data that you want to delete. Three, you should be able to update data. Four, you should be able to read data. And the only thing that can help you in SQL environment is what? A table. A table will help you to store your information, your data in a manageable form. And this table will be saved or will be residing in a database. And you can have a database that has many tables. In this case, this is a student table. And this student table, the information here is about what? The contact of the students' contacts. We have three students here, James, Anthony, and Anne. They have phone numbers and also have email address. It might be tomorrow, Anne changes email. I should be able to come here to remove this email and put a new email. That's what? Update. Okay. Also, it's possible that Anne is no longer a student and I don't need this information in the database. I can simply delete Anne's information. This row will go and it will not affect this other row. I've just deleted. What if there is a new student that just joined this school? Today we have just 3 students. Now we have another student. I should be able to what? Impute a new student information into this table. So that student is 103 and her name is Jane. door. Let's say it has a phone number of 01814718. This is the features number. And then email is jane@jane.com. See, with help of this table now, I'm increasing the number of rows. And in table, this is called what? Rows. This is row, each of them. And these are columns. All these are columns. This entire column represent what? Particular what? Property. Student ID is a property that is general among the whole student. All the students have the property called student. It's like every human being has what? Eyes. So this is our property. Okay? Or I say, okay, we all have nose. Okay? We all have nose. Our property. So this group of students, there's something that's common among them. Student ID. They also have something common, which all of them must have, is first name. This one, last name. This one, phone number. These are properties. But each of the row represents one was student. This is student. Okay? So a table is needed because it will help us to manage our information. Present it in a way that we can understand the information, in a way that we can manage what? The information. Okay, wow. The next thing is that how would you create a table? How do you create a table in SQL database? To create a table, all you have to do, simply say create. Because you are creating a table, not a database. Remember when we are creating database, say create database. Now it's a table you are creating. Say create table. So the system now knows that what you want to give a name of the table. Assume this is a student table. Just say, okay, just create the name of the table is student. You can call it anything you want to call. Okay? This is the first thing you need to do. The next thing now is, as you can see here now, the title is not only what is here. Aside the title, we also have what? Columns. It's like you have eyes, you have nose, you have mouth, you have hands, you have legs, and your name is, let's say you are human. For instance, I say create human, then I give the name of the human. I say the name of the human is, and then you want to put here, now you put it. For instance, as okay, the name of this human and H1. For instance, that is the name I'm giving to them. Then if I finish, I should be able to describe the properties of this human. The first thing I will put, I was okay. I put brackets here. I say number one, he has eyes. I give what? The type of eyes. I say he has hands. Okay. Hands will be here. And this human has what? Leg. See? All the property. Started measuring them until I finish telling us about the property. And I need to tell them, these eyes, what are they made of? Are they made of sand? Are they made of liquid? This one, what is it made of? What is this one made of? Okay. I will just give you this funny example. That is the same way we are going to create table. I am doing this for beginners because when you start like this, it's good you start from the known to the unknown. I know you know what is human, how to create things. Now I'm creating a table in this world of what? Database. It's a word. Like you have planet Earth. Look at this as planet database. And what lives in database are tables. So I want to create a table for students. Okay. But because this student is nothing without what? columns. I should be able to tell the system the names of the column. The first one is what? Student ID. So I will tell the system the first column is student ID. What type of data will be living in this place? In this place, what type of data? We are going to do that one in our next class after this, because it's very important. I don't want to rush it. We're going to look at it next. The next column will be student name. Remember this one, aside column, you can also call it what? Feed. The name of this column you are seeing, you can also call the what? Either you call it what? Column, or you call it what? Feed. So the name of this column, the next one is first name. What type of data will be staying here? The next one is what? Last name. What type of data will be staying here? Phone number. What type of data will be here? The email. What type of data will be here? But what you should know, because this hence here, you have to put a comma to show that I want to give another property, another comma, another property, another comma, another comma. The way you get to the last one, do not put anything. It means you are okay now. You now close with this first open bracket. You close it now. Close, put your semicolon. Understand this? What we have not treated here now is data type. What type of data will be staying here? Data types. What type of data? Please, I need to know. I am not a magician. That's what database is telling you. I am not a magician. What type of data do you want to put here? Because once you give me the type of data that will be living in this place, I will not allow another type of data to stay here. I bound this name. Please note, you can write student ID, for instance, like this. Student underscore ID. They must be together. You can also write student ID. You can write everything, just everything like student ID. But you can't do this. Student ID. We don't allow space in between the ID. There must not be space. It will give you error. If you want to have space, you put what? Backtick. To show this is the way you want it. Okay? And also, do not use my SQL keywords like the word create now. You cannot come here, for instance. Okay? The data that is here is called what? Create. Say create. Or you say the data that will be here is called database. These are keywords, or delete all those keywords. Now let me just show you what I'm saying so that you have a picture of what we are saying. I don't want to believe that you're a beginner. That's why I'm doing this. Okay, for instance, if I want to create that table, I will simply say what? Create. Are you creating database or table? I want to create table. What is the name of the table? It's called student table. So tell me the properties. What are those things? The columns name. The first one is student ID. What type of data? I will tell the system. Then I put comma. The next one, as okay, is the first name. Then I put this, the type of data, I put comma. The next one is last name. You put this, comma. You say, okay, the next one is phone. You put the type of data, you put email. You have just created what? A very simple table. Now, I've removed every other information, remaining only student ID, which is possible. I can have a table with just one column. Now, let me put the data type, make this one int for now. I want to create this, then I want to create another one. Same. Create another one, same name. On purpose. This semicolon means this query is different from this query. This is like a separator, separating this query from this query from this query. If I want to execute only this, I just click on this one. Okay. If I want to execute everything, I click on this. But if I also want to execute only this, I can use this one. Just select. You can see execute the selected one. If there's not that selected, everything will be executed. What I want to ask you, is it possible for 2 tables or 3 tables or more to have the same name? No, it's not possible. Why? This is a database. As I said, imagine it's a house. They all live together. Assume they are siblings. Your name is John. Your brother name is John. Your sister name is John. When your dad said John, who is going to answer? It's not ideal. It's not a good one. So the only way you can do this, you have to make sure that the name of the tables in the same database cannot have what? The same name. As I said, tables in the same database cannot have the same name. It must have what? Different names. Because if this is a house occupied by 3 siblings, your name is John, your sister is John, your uncle is John. Oh, how is it possible? This is not a good one. Everybody should have what? A unique name, because this is a database, for instance, that is housing this what? These tables. So each of them must have what? His own name, unique name, to show in case I want to call this guy or I want to call this guy, they will answer. How do we call tables? We want to select something from this table now. I will say select. Whatever I want to select, I put it here. I say from the name of the table. This one. If I say John, who will answer? Nobody will answer. It's like confusion. So the system will give you error. The same thing goes for this. I will go ahead now. I create this one. I click on this. It say what? Created. Now let me create this one. To not allow you now, it say what? Students already exist. Let's try this one. Students already exist. It will not allow you. So to create it, put to here, then you cannot create. For instance, this name now is not unique, different from this name. If I click this, it has gone. Good. Have you done this? I want to show you another thing. If I call this one, for instance, I say, okay, this one is not employee. Okay, this also employee. We have agreed they cannot bear the same name. Let's say employee 2. They can't bear the same name. That is clear. If I say employee ID, for instance, can I also say employee ID here? On 2 different tables? Of course, you can. Though they are in the same database, this guy lives here. This guy lives here. Another guy lives here. Okay? I want to ask you, this is a property of this table. Your hand is your property. Does this one have hand? Of course. Can have the same name if you want. This one have hand? Of course. The property can bear the same name. There's no problem. But is their name? Because when I'm calling from outside, somebody should answer me. Exact person should answer the call. But inside, we all know that what you have, I can have it. Your properties. But the identifier, your name that identifies you, must be different. So if I go ahead and create this one, it will go, as you can see. If I say create this one, it will still go. Because they are inside different tables. That leads me to the next one. What if I want to create another employee? I use comma here. Employee ID. Is it possible? I will see put same here. Employee ID. Now I have to change this name to, let's say 4 and 5. Different name now. Is it possible to have same property or same color feed in the same table? No. Because if all of you are in database, these are all the tables in the database. Okay. These are table. Now this table, if I want to tell the database about hands, it's only once. About hands. About leg, it's only one. The same thing goes for this one. If I want to say employee ID, it's only once for this guy. Though I can also do the same thing for this guy, that is this one. But for this one, it's only once. If I repeat the same thing for it, it will give me error. What I'm saying now, let me pull this guy out of this database. Okay, I'll pull this guy out of the database. Okay, this guy can only have one property. I say this one is hand, this one is leg. I cannot have hand. That means this name must be unique. That's what I'm trying to say. Must be unique. If I drop this now, let's see if we go. Say no. Duplicate column name, employee ID is not allowed. But if I change it now, what will happen? If I drop it here, it accept. Let's try for this too. Duplicate is not allowed. Hope you understand this point. When do you use if not exists after create table statement? So what you will learn in this class is if not exist. Please don't worry yourself about all these ones. What I want you to concentrate on is create table. Create table. Create table. How many table? This is S1, one table, same table, another table. What is the purpose of this? This one will create this table because it's not already in the system. To check, let's say show table here. Let's run this. We found out what there's no table in the database yet. See? There's no table. Then this will create this table successfully. So if I drop this to run now, at this stage, this table will be created. When this system runs to this place, as it's running this query, it will find that this S1 is already here. It will return an error. It will stop here. It will not create that table. That means it will not get to this stage. Okay. Let me remove this one first. Select all. Run. It says query interrupted. Where? Interrupted at S1 already exists. That is this second place. Now let's go back and put this show table. Let's see the table that has been created for us. See, only S1 was created and it stopped at this stage because S1 was already in the system. It couldn't get to this place. But remember, this one is not in the system yet. It couldn't get to this stage because it got an error here. That is that point. Let's check another one. This is M1. We are using if not exist. Create this one. Same M1. If not exist, create it. Another table, M2. Why? Want to see that we know definitely this one will be created. After creating this one, with the system stop here, with the ng stop here, or when you see the error that this one already exists, will it go straight to the next one I created, or will it have the same issue like this one that stop here? Let's see. I'm going to select all, then run. Look at it. At this stage, it created what? This table. This one, it just returned a warning telling us it exists, but it did not stop. It kept what? Running. It ran this one successfully. I created this one. Now let's see show tables. If we click this, we find out M1 was created. Right? Good. Although this one M1 is already created, it did not stop. It went ahead and created what? M2. That is what? The joy of what? Using if not exist. When do you use open and close curve brackets when creating a table? What we learn from here is how to use open and close curve bracket. This is to tell the system that we are about to tell you the structure of the table. That is the names of the columns, how they are designed. Then this is to say, okay, I'm true. this is the end of what? The entire query. Let's see. I say create region. Then here is to tell the system, I want to tell you the structure what? Of the table. This one sometimes is not necessary. If you don't put it, it will take the default. This is enough. Even this is enough. Even this is enough to create a table. This. The name of the table. This is one feed or one column. The type of data that will be staying here. We are going to look at this one later. You can even remove this one. You don't need to put it. Okay, like this. But this is, I want to tell you the structure of what? Of the table. This is the beginning to tell us about all that will be inside. And this is the end. And this is the end of the what? Query. The same thing goes for the bigger ones. Like this one. I'm about to tell you the structure of the columns. I will close it once I'm through. This is the end of the what? Of this entire. Hope you understand this. Let's move to the next class. When do you use backticks in create tables? Look at this. This is backtick. This. When do you use it? Majorly, SQL does not allow you to use its keyword as the name of a feed, that is column, or the name of a table. Even procedure, program, even trigger. It does not allow you to use what? A keyword. So what we do is, if you want to use a keyword like, instead of this shipper ID, you say create, for instance. Instead of shipper ID, you want to put create. A create is a keyword. You simply what? Use backtick to insist that what? You want to use a keyword. But generally, some people prefer to use backtick for everything. Why? Because in case what I'm using is a keyword or not a keyword, let me just go ahead. I don't want to know. I don't want to delay myself to know which one is a keyword and which one is not a keyword. I don't want to delay myself. I don't want to start telling myself this is a keyword, this is not a keyword. No. What I will do, any name I choose to use for my table, any name I choose to use for my column, I will simply what? Use a backtick. It what? Saves you from many what? Errors. Okay, let's see. Like this one now, I say I want to create a shippers table, and this is one of the table in Northwind database. As you can see, I can decide not to use this backtick. I will still achieve the same result, because these are not keywords. I will call this one shipper one. Let me create this one. It accepted. Let me say show tables. Agree. Describe shippers one. See? It accepted. Let me repeat this one again. This time, I put everything should be what? With this. I will call this one 2, shipper 2. Let me go ahead and put it. Accepted. Now let me go back and show this time. Let me repeat this one here. This time shipper 2. If I come here to put this here, see? Accepted. If I describe shipper 2, see? Same. One was created with what? With backtick. The other one was created without backtick. But originally, the purpose of backtick is like, if I want to create something like, create is a keyword. This is a keyword. If I want to use these keywords, maybe I put table here now. Table is also a keyword. That's why my SQL is making this bold. It's making this bold because they are keywords. If I try to create this one, let me put this one 3. I see if it will accept. Let me click on this. It's giving me error because I'm using keywords. These are meant now to remove this error because I want to enforce this, that the system must accept them. Let's see if it will be created now. That is shipper 3. It says shipper ID doesn't exist. Okay, that is this place. It's because of this place. Okay, let me change this one to this place. Then still put the backtick. If I hit it now, accepted. Okay, let me first of all show tables. Shipper 3 accepted now. Let me now describe shipper 3. See? This shipper 3. The same thing. So this keyword now is accepted because I use the backtick to enforce it. You see? I'm using the backtick to enforce it. But there are some time I want to create something, let's say shaper 4, then I want to mix it together, put insert. I said the name of this is what? Insert. And insert is a keyword. So what I will better do, I don't want to know if this is a keyword, start searching the documentation, to know which one is keyword, which one is not keyword. For my freedom, I will just simply what? Use backtick to enforce everything. Both here, everywhere. I just put backtick just to what? To avoid any form of error, because I don't want to know if it's a keyword, if that's not a keyword. So if I drop this now, it will definitely go. That's why some people prefer to use what? Backtick everywhere. But if you know the very one you are using is not a keyword, you have freedom to use the backtick or not to use backtick. Hope you understand this. Thank you for viewing. Create a simple table with 2 columns, customer ID and company name. See below. What you will learn? How to create a simple table. So this question is saying that we should create a table with customer ID, company name, and these are the details. The first thing you should do is to look at the values. What type of values? This is a string. This is a string. These are all strings. So preferably, you should use the varchar. But the next thing is, what will be the length of this varchar in this column and the length of the varchar in this column. If you use between 5 and 10 here, it's okay because of the range, or 7. Here you can use from 50 or 40, 45. It depends on you. Now let's see. The first thing we are going to do is to first of all create table. This is the first thing. Create table. You say it's for customers. Say customers. Okay. Then you open and close the semicolon. This place is where your columns what will stay. The first column is customer ID, and because it's varchar, you say varchar, and because of the length, we can put 5, 6, 10. Let's put say 5. The next thing, create for the second one, and this company name is also a varchar because it's string. For me, I can put 50 here. So I put a comma here, but there should be comma here before this close bracket. This is everything you need to know. Okay. But before this, know that you need to have a database created. So that means this one must go first. Completed. This one should follow. Completed. Then this one follows. Okay. To show if our table exists, you say show tables. Customer has been created. And to show the structure of this table, we say what? Describe customers. There you go. See the structure? The customer ID is the first column with this type of data, varchar 5. We are going to look at this other one later. This one is higher than this as per the range. Hope you understand this. What are the types of data in MySQL? Types of data in MySQL. Let's see. In MySQL, we have different types of data. We have the numeric data types. We also have date at time data type. We also have what? The string data type. We also have this one, which are not too popular, the spatial data type and the JSON data type. And one thing you must know is that in MySQL, when you are creating a table, it is forbidden to tell us the name of a column without telling us the type of data it is. It is not allowed. It's like even you, when you go out to fill a form, they say you should write your name. They will ask you sex, right? Are you a male or female? You cannot tell anybody, I'm a male, of course. Can't you see me? No, we don't know. I'm a female, of course. Can't you see me? We don't know. You have to write it down if you're a male or if you're a female. The same thing goes to datas. When you want to create a table for them, you have to tell the database system that what type of data is this? Is this data a numeric data? We are going to see the type, how to specify them. Is it date? Is it string? Is it spatial? Is it JSON before you can continue. Otherwise, you are doing the wrong thing. Now let's go straight to understand deeper the meaning of numeric data type. The first data type we are considering is the numeric data type. MySQL supports all standard SQL numeric data type. These types include the exact numeric data type and the approximate numeric data type. We are talking about data type, that is type of data. The world is full of data and we have different types. Because you are going to use them, you need to know what type of data they are and the one that are acceptable by SQL. The first one on the list is the numeric data type. This numeric data type still have two types. One is the exact numeric data type and the what? Approximate numeric data type. What is the difference between the exact and the approximate? As the word goes, exact. What is exact? 6 is exact. 8 is exact. This supposing how many legs does it have? Has 2 legs. So human being has what? 2 legs. These are exact. If I give you egg to count, how many eggs are here? 3 eggs. There's nothing like 3.5 egg or 3.5 egg. No, it's not possible. All these are exact. Then what is approximate numeric data type? The approximate numeric data type is one that does have uncertainty. You can see these are uncertainty, but this one what has what? Uncertainty. Approximate number is defined as a number approximated to the exact number. Okay, let me show you something. What is it to you? This is what? Pi. This is not even the end of pi. This is not even the end. It continues. As far as you can go, continues. What is this? This is the what? What we are using to describe this. I can even make it 3. Can approximate it to 3. This is what? The approximate what? Number. Why this is the exact number? I will call this one exact number of the approximate number. The number you can approximate is called what? The approximate number. Okay. For instance, now I say square root of 3. It can never be what? Exact. It's a fraction. Square root of 5. Same is a fraction. So you see, all these are what? Are not exact value. Numeric data type you will find in MySQL. Some are exact numbers, that is numeric, and some are what? Approximate what? Numeric data type. This one now leads to us for us to expand on this more. Now that you understand the difference between exact numeric data type and approximate numeric data type, let's now go straight to dig deep into what? The exact numeric data type. MySQL supports tiny int, that is tiny integer, small int, that is small integer, int, that is integer, or the big int or big integer. Okay, let me explain to you each of these with the table. Look at this table. So you can use the tiny int, you can use the small int, you can use the medium int, you can use the int, you can use the big int. What is the difference between these 5 types of exact numeric data type? Number 1, they are exact. That means there's nothing like dot this, dot 00. No, they are exact. Just the way you should write 4, you write 7, they are exact. All of them here are exact. But this is where the issue is, or the difference. The major difference is their capacity to store data, their ability. What you will give to adult to carry, you will give it to a little baby. Right? That is the difference. Tiny int is like a baby. And what it has capacity to carry is just 1 byte. And a byte is 8 bits. Small int without bit code is 16 bits. This one is 24 bits. While this one is 32 bits. And so on and so forth. Now, we have discussed their storage capacity. Let's now see the range. As you can see here, we have 2 types of value, though I'm not talking about this, not about the maximum yet. I'm talking about this and this. What are the difference between sign and unsigned? Sign number or sign value is something that has minus before it or positive before it. Like sign is like -2 is a sign value. Okay, this is sign value. That means this first one indicates the sign, but unsigned value, they don't use sign to indicate, they only give the value. If you have done physics or maths, you know we have something we call vector, we have something we call scalar. We agree in physics that a vector quantity is something that has what? That is a value plus what? Direction. Why this one what? Only has what? The value. The same thing with unsigned. Unsigned only indicate the value. The value. It doesn't have anything to do with the sign or the direction. This one, the sign deals with what? The direction. Which direction are you going to? Is it negative side or positive side? So sign, take care of that. It's like the vector of what? Exact numeric data type. Okay, now let's continue. The first one we're going to deal with now is the signed for all of them. Remember, sign will indicate the direction and the magnitude. That is a value. For tiny it, remember if you are writing 0 to 10, you write like this. If you want to go back, say -1, -2, -3, -4. For sign, this is how it goes. You want to know your direction. So for tiny it, the direction starts from where? -128 to +127. That means somewhere here, 127, somewhere here, -128. But I want to ask you, if you want to get for, okay, before I do that, let me continue first. The same thing with this one is that it has more capacity. It extends because see, the capacity is more than this. So this one is more powerful. So the negative side is farther. The positive side of this is farther. When I say farther, I mean farther than the other one. I will say that this one's same. Increasing the capacity, increasing the capacity, increasing the capacity. That's all of them. So the capacity is, this one is arranged what? In ascending order. From the smallest to the biggest. Remember, this join with this without direction is equals to this. How do I mean? If you are going for the or sign that is not interested in the direction, or sign will start from 0 going forward. Okay, if you look at this, okay, let me just do something for you, something that is simple. I say -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, if I want to know the magnitude of everything from year to year, as I can see here, I will simply say 4 plus 4. I will say what? 8. This is the magnitude without considering what? The direction. That means I forget about I take the highest one. I forget about the sign. I take the highest one. When I add them together, I have 8. But if I don't want to waste this one like that, I say, okay, I want to rearrange this 8 without any direction. I will start with 0, 1, 2, 3, 4, 5, 6, 7, 8. This is, for instance, the assigned. Why this one? It is signed. So the same magnitude, because the length that this one is covering, that's what this one is also covering. But the only difference is that one has direction. It divides itself into 2, put half to one direction, I put the other half in the other direction. I will say this. Let's confirm. What I'm trying to establish is that though you see signed, you see sign or sign or sign, doesn't make this one different from this one at all. They are the same thing. They are not speaking different language. They are speaking the same language. If you add this to this, Talking about the signed, without considering the duration. If you consider the duration, I know if you add them with the duration, you have -1, but we don't want to consider the duration. Just say 128 plus 127. What you have is 8 plus this will give you what? 15. Take 1, this one will be 5, this one will be 2. That is this. If you add this one and this one, you still have this. Add this and this, you have this, this. That is what we are having here. But what I want to ask you, what is the difference between this sign value and this sign value? What can you see at the back? If you want to look at the figure only, just remove one from here, you have this, right? You remove one from here, you have this, right? You might say this is not necessary, but you need to understand some things, okay? If you remove this one, you have this. That is the difference. The difference is just remove one, I have this. Why am I explaining this one to you? Even this one, if you remove one, you have this. Every other thing remain the same figure. Now we come to this one that is very large. To have the corresponding value, what we are doing now is still the same thing, but we don't know the value, how we can get there. To write it is too much. We just remove one. The way we are removing one from this, to have all these ones. We also remove one from this. That's what we are having here now. Okay? And you agree with me? If you add this and this together, you have this. Okay? You have this. And so on and so forth. Hope you understand this. So these are what? Look at it again. They are exact numeric data type. The tiny int, the small int, the int, a big int. For instance, now you want to do something that you know that, okay, I know actually that there is no way that the value I want to put, okay, like as a student ID, I'm choosing big int as the data type, this one. But I know that this is very large, or very large. You'll be wasting a lot of what? Memory space. Look at the byte here, 8 byte. You are wasting a lot of memory space. At the end of the day, you might end up using little part of it. What about these ones? The best thing to do is to choose the right one that fit your data. Okay? Choose the right data type that fit your data. Though there are many here. If I want to write something like 1, 2, 3, just to 9, for instance, I don't need even to 8 or whatever. I don't really need too much. I just use tiny int. Okay? Hope you understand this. Now let's go straight and look at this one. The approximate numeric data type. Thank you. Now let's see. You already know this tiny int, the small int, the integer, the big int. What I want to show is that though you can put the size like say 10, but there is no need for all this integer, because at the end of the day they still remain integer. This is bit depreciated. Specify the value. Like for instance, let me go that. Yeah, look at this. This is what we are going to treat. We're going to shrink. I'm just running ahead of time because I want to show you something. This now you must specify the size of what you want to store in this column, the maximum size. I can say for instance is 50. That is the maximum. Okay, for me this is what I'm choosing. You can choose 100 if you want. Depends on you. You can choose 255. That's you. If you don't choose, the system will give you error. For the integers, the tiny e, the small e, the integer, the big int, you are not required again at this time to specify this, because this is being depreciated. So what I will do first is, now that I've done that, this column or the field will be called student ID. I will go ahead and run this. Okay. If I run it, accepted. How do I know if it accepts? I will go to say show table. Click this, it show that what is accepted. This table is here. if I want to describe a table, I can say describe that table for me. What type of table is that? This one being describe table. Tell me the structure of the table. I come here, I say describe the table. It's telling me it only has one column, that is feed. And the type is what? Tiny int. We're going to show all those keys, the default, the extra, everything. We're going to show them later. But what I want to let you know is that once you say this is the feed name, this is the type of data, you are ready to go. But the point is, if you like, you want to, okay, assume I come here now. I want to put 10 here, though I shouldn't. It's not giving me any error. I can still run it, but it's going to warn me. See, it said integer display width is depreciated and will be removed in the future release. Does that mean it has not accepted this? It accepts. Let me show tables if that particular table is there. Now there are now two tables. This one is there. Okay. And if I say you should describe it for me, I say describe table student 2. Let's see. Yes, it say what? It's a small int. See it. For this, I can easily say go. It will go. See, no error. And if I check if this has been inserted or created, that is number 3, I will find that it has been generated for me. Show table, or the table that in this database is there. If I describe it, you find that there is no difference between it and the other ones. You see, it's still as it is. So what I want to let you know is that for integers, specify the size like this. It's no longer needed. Let me just remove this one so that I show you this one before I will get to this topic. Assume I refuse to put this. Can it go? Let's see. You have error in your SQL syntax. Check. Now, assume I put this. Will it say allow me? Let's hit it. Same. Or let's specify now. This one you have to specify. You click accept. If I come back and ask you, I want you to describe me table 4, which I know is there already. Okay, to show me that what table 4 is there, and say what? A voucher string. Hope you understand this. Very important to know. If you want to create a table, create table. You give the name of the table. This one will tell us about the structure of the table, the properties. The first one is the first name. For this, it depends. You can have as many as you want. It depends on what the structure of the table. Hope you understand how far you have gone. At this time, we are going straight to dig deep into approximate numeric data type.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
The approximate numeric data type are 2. One is the fixed point types and the floating point types. The fixed point types, the instance of that is the decimal type. You can also call this one, or in place of this one, you can use this type called what? Numeric. I mean, in your syntax, you can virtually replace this with numeric. You have the same output. So whatever we're going to talk about, this decimal is also applicable to numeric. Now let's look at decimal in detail. In details, then we'll come back to float and double. That is looking at fixed point data types. The decimal and the numeric data type store numeric data value. Okay, the first thing you should know, they store what? Numeric data value. 2, these types are used when it is important to preserve the exact precision. Okay, exact precision. Where you want to what? Preserve the exact what? Precision. For example, somebody deposit money in the account and the deposit was 100 USD 50 cents. It must be exact. No addition, no subtraction. If you put extra 0 here now, you are calling this $100 500 cents, which is not the same thing with what? $100 50 cents. So when you have this type of data, all you want to use is the decimal or the numeric data type. We are after what? The exactness, but the precision of what? Of that data. We say what? Fixed point type. That means this one, without B2, you should know that what it be floating. Like this one, there can be forgiveness in the way the result comes out. Like you put extra zero here now, like in scientific work. I will say that. Let me show you. So in my SQL, numeric is implemented as what? As decimal. Okay. Now, let me give you something like this. Assume you have something like this. Salary as your column. Let's say create table. Let's say deposit. See, the first column is salary. The data type is decimal. You say, okay, it's 6 to 2. For instance, what is this? This is what? The precision. Why this is what? The scale. I will explain to you. What this one will produce, this one will likely produce things like this. You have 4, 6, 7, 9, 5, 8. How many? 3, 3. That is 6. This is what it's saying. Then this scale will be here. That is 1, 2. That's what we are saying. For instance, let me move further. I'll explain that. If we have something like this, 8, 9, 4, 2, 1, 1, like this. Put dot here. That's what this one is saying. This 2 is this one, the scale. 1, the total number, 1, 2, 3, 4, 5, 6 is the precision. So remember, the precision is very important. We must be definite about what? The precision. So the precision is present the number of significant digits that are stored for values. And the scale represent the numbers of digits that can be stored follow the decimal point. Okay? Follow the what? The decimal point. Let's assume that there is a demand in your SQL. And you put something like this. You say decimal. You say 4 to 1. What are the data you can store here? What you can store here is minus 9, 9, 9, 9. How many 9? 4, 9. Where are we going to put the full stop here? Is here. 2 plus the same thing. Where are you putting the full stop? Is here. So the value that can be stored in this column, like assume this is a salary column. This is the what? The size from this to this. What it means is that I can impute negative value like minus. Assume $1,000.1. This one negative means overdrawn or you took a loan. Okay, this value can be here. It might be that instead of 1, I put 2 here. That means I have to remove this. I also remove this. Then I can fix this one here. I fix this one here. Remember, I did not change these significant values. I only change the position of what? Of the decimal point. Because it's this scale that I changed. I did not change this one. But if I have something like, let's say, your deposit, or let me say, there's a credit that comes to you, assume another decimal. You want to store something in 8 to 2. That means what you can put there is how many now? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Then the dot to be here from this negative to 1, 2, 3, 4, 5, 6, 7, 8 here to positive value. This is the range that can be in this column. You understand that? Okay, let's move further to explain the decimal. In SQL, if you have this type of, when you also create table, assume the name now is, let me say income. You now say, okay, here is your trading, and you want to put it in decimal. Whatever you put here, if you put only one figure here, assume what you put here is M, only one. What it means, the default of this, or the equivalence of this is decimal M0, meaning if I have decimal and I put 4 here, let me say 5 this time, 5 here, then it simply means decimal 5 to 0. So the value that will be here now are, for instance, you have 5, 5, 4. Let's put 2 here, for instance. 3. How many precision? 1, 2, 3, 4, 5. That is okay. That means there's no place for what? For the scale. We are not going to put any full stop. You understand? No full stop. That is the meaning. If you have anything like this, it's equivalent to what? 5, 0. Meaning there's not going to be any dot anywhere. This is the default. You should understand. Remember, everything we are saying about this decimal is also applicable to what? Numeric as a data type. So if I have something like this now, for instance, I have, even if I don't put anything here, let me just remove these ones. Assume I don't even put anything here. So the system can decide for us the value, whatever I want to do with that place. But the default value is what? Is 10 here. Is 10. I mean here now, the default is 10. That means if I don't put anything, I am allowed. But know that what you are doing indirectly is 10 to 0. This is the meaning of not putting anything. This is the meaning of not putting anything. This is the default. When I do decimal, this. Okay? The next thing we are going to do now is to look at how to use this numeric and the decimal. Remember we said they are the same. Okay? You can either use small letter or capital letter. It depends on your style. Now let's look at this. You see, I've gone ahead to create this database called income. So the first thing we are going to do, let's create this database with only one column. Only one column, that is a field called numeric. Remember I said by default what is here is 10, 0. 10, 0. The same thing with this place, 10, 0. That is what is behind the scene, which we are not seeing here. If I leave it like this, that means there will not be any place for the scale, the full stop. So let me create this. I see created. I want to insert this value. This is how to insert value. We are still going to look at how to insert value. Click on this. We inserted the first one. Now let's see, before we continue, we say select this from. We are still going to treat this from deposit one. Then we do this. Let's see if this value we just enter, how it comes out. See, what I will do now, I will go ahead and click this. This is how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 altogether. Let me click it. Okay, let me check what happened. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, right? Now what I will do now, we copy this. Deliberately, I will add about 2 digits here to make it 12 now, right? Let's see. Error. What does it say? Out of range for column amount, because by default behind the scene we have 10 here and 0 scale, and this one is beyond 10 values. You can't take it. Let's look at this one. Remember, there's no place for dot, or we come to this one. Let's enter this. It's giving us one warning. Data truncate for column amount at row 1. That means this is truncated. You will not see it because we already have 10 there. So you see, we have this 10. Now what I will do, instead of 10, let me make it 11 so that you will see clearly. We are tracing if it will be able to put this dot 2 where we make it normalize this without putting anything here. Okay, if we click, let's check what is the system now. Look at it. Is it telling us it has truncated? That means please, so be careful. If you really need this, I am truncating it. If you don't want it to be truncated, correct it, or go and correct your what? Your data type. If I click on this, you find that it's only 11 because there is no room for scale, the dots. The same thing is applicable to this, the same thing is applicable to this. What I will do now, I will copy everything here. I go down, repeat the same process for this one I call deposit 2. Now I'm using decimal before I use numeric. Let's confirm that two of them are the same. Okay, what we're going to do now, first of all, we create it by clicking on this, accepted. Let's click this one now, accepted, because it's just 10. Will it accept this one that's out of range? No. This one with scale? No, truncated. Now let's check this deposit 2 now. See what happened? The first one accepted, the second one accepted, this one is out of range, was not accepted. This one, you remove what? This particular one, truncated. So assume I put still truncating it, but what we check, let's not check what is there. See, truncated. So note what I was telling you is true. So let's continue to explore what we have been saying. The next one we are going to explore now, we're going to pick the whole thing again. Let's just go back. This time let's create deposit 3. Okay, all this one should be 3, 3, 3, 3. What are we going to do this time? We're going to put decimal here. Remember, anything for numeric is also for decimal. So now we are not going to waste our time because we have confirmed that. We just have to put something here now. Let's put the scale. What scale should we put now? Let's put 5 to 2. Then we are going to increase this one to, remember, it needs 5 all together. Then we put this dot somewhere here. This one now is beyond 5. This one too, let's see, 1, 2, 3, 4, 5. Okay, let's make it exactly 5. I see I to do it. Let's also make this one exactly 5. 1, 2, 3, 4, 5. So here exactly 5. Here exactly 5, but beyond the total number I can handle. So that means everything here is 7. Everything here now, let's now make everything here. Let's make it exactly 5. Okay, let's see the way to handle it. Okay, this one is beyond the range. This one is exactly. Let's put one that is what? Far below. Let's say 2 or 4. Okay, let's hit it now. We come here, we click on this. Let's just select everything, click on this. It's just that we could not confirm, but it's telling us that what? Deposit 3 4678. 4678 is already complaining. Column amount at row 1. Out of range. See, out of range. Why is it out of range? 1, 2, 3, 4. Okay. Now let's see. Let's click on this. That means it did not even execute this one. That's what it's telling us. It stopped at the first row. I wanted to put everything once, but happily it did not accept. Now let's check. See, nothing was entered. You are asking yourself, what is the meaning of out of range? Now let's put extra here. No, let us not try that one here. Let's try this one now. See, out of range. How many? 1, 2, 3, 4, 5. What is the out of range here? Let's now put dot here now. Remember, 1, 2, 3, 4, 5. The position is here. Okay, let's click accept. Now let's check exactly. Now let me ask you a question. Why is it not accepting this? But look at it. It's giving us an error, but he accepted the one with dot. And if you check, that was what happened. That's what I was telling you, that this one is fizzed. Remember, fizzed. I can't stretch it enough. I can't stress that enough. It's fizzed. But we have a floating point, that is .33, for instance. We have something here, though it has a floating point, but it's fizzed. You can't amend it. You can't change anything. You must do it exactly the way it asks you to do it, because it's like you want to input value of dollars or your currency. I don't want to compromise. Please give me the exact scale. Give me the exact what precision. That's what it's saying. That's why it's complaining. So if I come back here, let me put this one out. Remember, this one is out of range. It's not going through error. If I will reduce it by 2, though it's not 5, it will not still go because this precision is missing. So let me click on this. It's not still going. I'll make it lower. Let's click. It has gone now. Now let's see what it has done. Let's see what it has done. We come here. We find it added 2 extra. You see? Okay, good. It added 2 extra. But if I come here now, I put, let me say 5 here. Or let me just put 8. Okay? You will see what will happen now. It will not go. Why is it not going? Because here it saw that you gave 167 and the system says 5 is the word precision. So that means if I put extra 2, 1, 2, 3, 4, 5, I am still perfect because 2 is the scale. But here, you look at this one, it's okay, 1, 6, 7, 8. If I put extra 2, which is a mod because of this indication, if I count everything, 1, 2, 3, 4, 5, 6, it's not beyond the number now. You see, it's not beyond the number. It's supposed to be 5. Therefore, there's no way I can put full stop here. Everything will be more than what? 5 indicated. Therefore, error was returned. You understand it? Like this one now, it cannot even go. Like this one now, it cannot go because we know that everything is 5. 1, 2, 3, 4, 5. But the scale is supposed to be somewhere here. Now let's see if it will accept it. If I click on this, error. Okay, what it says? It says truncated. That means I know definitely you have 1, 2, 3, 4, 5. But you ask me to do this type of format. Whatever I'm doing, there should be only 2 after. So what I will do, I will truncate it here so that what is after the full stop will not be 3, it will be exactly 2. So if you check now for 82, you find that it's 82.79 but approximated this. Now let's look at floating point type. This and this as at MySQL 8.017, they are all depreciated. So we are not going to waste our time on these ones, okay? We are going to study another type called real. Okay? We are going to look at real. But it's all the same thing. It's just that this one is depreciated and this one too is depreciated. Okay? And the support for this and this will be removed. I will say that, remember, it's floaty. It's not as rigid as this. The possible scenario where you will use it is for scientific research. Okay, let's look at real now. If I write real and I do something like this, MD, what is the meaning of this? This tell me what? The precision. Why this is what? The scale. Where what? The dot will be located. The one we have seen before. There's no big difference. It means if I say real, I put 5 to 2, or let me say 6 to 2, I should be expecting something like this. If I have this, they cannot be more than 1, 2, 3, 4, 5, 6. Then this one will be here. Or it can also be minus, it doesn't matter, because that is the meaning of this. Okay, now let's create a table called test. We are going to create one column. Let's call the column, let's just say code. Let's say code 2. Then if you put float here now, look at the warning. Although it will still accept it, but if we send you a warning, let's see the warning. If I click this, Is there any warning? Yeah, look at the warning. See? It's going to be what? Depreciated. Though you see accepted it, let's see. If we insert a value there, for instance, it will see accept. You see insert into this. This is out of range for code 2. Why is it out of range? 1, 2, 3, 4, 5. 5, right? Remember 5. I will tell you why it is being depreciated now. This is 6, right? That means I want 3 here. Okay, 1, 2, 3, 4, 5. If you want to put the extra 0 now, like the output should be dot 1, 2, 3. Then it will be more than 6. 1, 2, 3, 4, 5, 6, 7, 8. More than 6. What are we doing now? Are we not repeating what we did for decimal and numeric? So what is the purpose of float and double precision when what is doing is what we did with decimal? If I want this guy to really go, what I will do, I have to reduce the number. With this, even though it's 3 extra, it will not be above what? 6. If I click, it accepts. What I've proven to you now is it's not because of the depreciation. No, it's because of what I defined here. If I check it now, I will see it has added those 3 figures. It is not the same thing with decimal. So what is the purpose? That is why it is being depreciated. So the only thing that is needed now for floating points, that is the floating point. Remember, you have 2 types. The approximate numeric data type has 2 types. That is the fixed point and the floating point. For the floating point, the best way to do it is re. I will tell you the purpose why. And for this re, we don't need to put the precision, then we put the scale. No, we don't want this. If I do it like this now, if I put, this one is 2, right? Okay, let me also put 2 here. Let me put 2 here. If I do this, look at what it will give to me. It's also what? Warning me that this for now is not needed. Why are you doing this? Although if I insert something to it, it's not that it will not accept it. Let me reduce this one so that there will not be issue. It will accept it and it will return me what? A value. But the point is, what is the purpose of doing this? I will tell you why now. If I put this now, look at what it will give me. It will not even allow me to do that. What we have just done here now is exactly the same thing we did for decimal. So why do you have decimal, you have re? Why do you have decimal, you have float? Why do you have decimal, you have double precision? So re is coming to help us, to give us flexibility. If I put 3 here now, or let me put 4 here, I change this to 4. If you want to put anything you like for instance, I can put anything here now. For instance, I put this. You see? Don't specify anything here. Let's create this. If I have not created it, yeah. Went. See? I did not put anything here. No complaint. This is what is expected of us now. Next, if I click this, look and see what will happen. It accepted it. Allow the system to do it for you. Garbage in, garbage out. That's what this one is saying. Garbage in, garbage out. Don't restrict me here. Please. If you want to use restriction, go and use decimal. Or you use what? Numeric. You can do all the restriction that you want. But since there should be a way, at least, if there's a way to restrict somebody, there's also be a way not to restrict another person. You should have what? Option. That's why this one is said. Let's see if this one actually comes in. If I click this, look at it. You see? Everything what? Inputted. Even though if I reduce it, for instance, that's okay. Now I just want only this. For instance, garbage in, garbage out. If I enter, I come here, let me see what is inside. Exactly the same thing without adding anything. If I want to add something by myself, is this not lovely? Just add by yourself. I will not change anything for you. If I put this here, I have what? Exactly what I put. Input. I'm not going to approximate anything for you. You would have put, for instance, I put, see, you click this. If you go back and click this, you have the same thing. Garbage in, garbage out. That is the work of re. You understand now? The double precision is being depreciated because what you are doing here resembles what? Decimal and numeric. Okay? This guy called float also depreciated because of the same reason. MySQL is giving you real. With read, don't put anything here. Garbage in, garbage out. When you are ready to define the specificity, go for decimal and numeric. If you know you don't have any floating point, you don't have any decimal point, all you have to do, you go for the int group. Either the tiny it, the small it, the integer, or the big it. This is string data types. We have char, varchar, binary, var-binary, blob, text, enum, and set. In this first section, we are going to look at the difference between the char and the varchar. One of the major difference you should know about char and varchar. For char is for fixed character, fixed. Why this one is for what? Variable characters. As the name goes, char, that is character. Var mean variable character. You see the difference? And you should know that this one, as I've said, is for fixed length. For instance, if I declare char and I want to put something in that place called female, and sometimes this colon can also be what? Male. It means the title now should be sex of the person. So if your name is James, you are male. If your name is Anne, you are female. Another person's name is Peter, the person is what? A male. So I agree with myself that these are the only two things that will be in this column all the time. I can declare this one as what? Char. Giving it what? How many? This one, 1, 2, 3, 4, 5, 6. So I can make this one what? 6. But I know if I make this one 6, there will still be remaining how many? After this one is 4, we still have about 2 remaining. It's okay. The joy of this is that when the system is saving this information, it will save it in the register. For this guy varchar, you can save anything. Like if you want to say the word dictionary, you want to say the word any length, it will take it. Even I, please, just name it. As long as the word is as short as it is, just say varchar. Then you can declare like 255, for instance. So what is here is that is variable. It's like what we did in numeric, or what we did in numeric, where we saw real. We say real can be used to save anything. Here the same thing goes. You can put anything you want to put as long as you give enough space. It's very good. But this guy is fixed. So when you are saving this guy, that is character, the char, if you are saving anything declared as char, the system, for instance, this male, it will save male. It will still pad the remaining 2 empty space on it and save it in the register. When you save it in the register, if you want to retrieve this information, it will only give you male. It will not return this empty space with this name. It will give you the exact name. But for this guy, for instance, if I've saved the same thing, male, maybe mistakenly I put white space with my hand. Not that the system will assign white space. Here, you mistakenly put white space. The system will save it like this. And when it's returning it, it will return it exactly the same way. It will not what? Remove them. Here, even though you mistakenly put the white space evil, when it's returning it, it will strip this trailing space away from it. I give you what? The original intention, the original character you wanted to put there. But this one, any mistake you make will be returned to you. You see the difference? Abu said, what is the capacity of service here? For this char, it can hold what? 255 character. Why this can hold how many 65535 characters. This one uses what? Static memory. As I said, why this guy use what? Dynamic. And this one is not registered the what in register. It registers somewhere. But that particular column, which you are seeing, will be used to reference that location where the information is located. But this one, the difference now therefore is, if you want to retrieve this information, it is faster, other char. But for this varchar, it can be slow. Okay? Invariably, when you know that the size of the character you want to save is consistent, use char. If you know that it is not consistent, use what? Varchar. Now let's look at binary and binary. Binary and binary, they are similar to char and varchar. The only difference is that why this one store directly in string, this one what? Store binary string rather than non-binary string. You understand the difference? This one store what? Non-binary what? String. Why this store what? Binary string. That is, these two guys, furthermore, store byte string. Byte strings. Rather than this one, that store what? Character string. It means that binary and binary, they have what? Binary character set and the collection, which is used for what? The conversion. Another thing you must know is the permissible maximum length that is required by binary and binary is what is also applicable here. The way you have seen it in char and varchar. Talking about what? The permissible maximum length. For this and this is the same thing with this and this. Don't forget, this guy is measuring what? In byte. Why this one is measuring what? In characters. So that's to tell you, this guy store what? In string. This guy store in what? In byte string. The direct computer language. Human language. You need to know the difference, as it is very important. But if you want to move information from here to this place, what do? You decode. If you want to move from here to this place, what do? You encode. So everything must be encoded before it can be written to a disk. And it must be decoded before it can be printed on the screen for you to see and read it and understand it as human being. That's why we are saying this character, this is byte character. Hope you understand the difference. For the ability to store, the size, everything, they are all the same. The only thing is that this one is closer what to the hard disk than this one. Hope you understand. The next thing now, we are going to go to what? Blob and test. Now let's look at the blob and the test types. The blob and the test, they store what? Strings. But the difference is that this one stores what? The byte string. Why this one store? Character string. All these blob sets have binary character set and collision. Test group. The test group are treated as what? Non-binary string. So their collation is based on what? Character set. While this one is based on what? Binary set. And what you should know about them is the sorting are based on the numeric value of byte in column values. Okay? If you put something like, just assume U and convert to byte, the sorting is based on what? The numeric value of the byte equivalence of what? Of U that goes to this place, and so on and so forth. These are not common. You rarely use them. I just wanted to look at them because they are part of what we are treating as what data type. In order not to waste too much time on this, let's go straight to the enum and the set. Thank you. Okay. At this time, let's look at enum. What is enum? Enum is different from all the data type we have treated. Why is it different? Because as the name goes, it's all about enumeration. How? This type of data is an enumerated list of data starting from 1 to 65,535 strings, indicating the allowed value for the feed. What I mean is that before now, if we want to define something, if I say name, you put the data type like voucher, you say 50. For enum, is the other way around. If, for instance, you want to buy a shirt, I say, okay, the column we have shirt, and it's going to be enum. Enum we give like small. See, the next one is large. The next one is what? Extra large. You see? Enum is enumerating what? The allowed list you can use to achieve what you want to achieve. For you to get it better, let me go to Workbench. Look at this. You want to create a table named shoe. The first column is brand name, as in what? In voucher. That means variable character are allowed to enter. Then you say, okay, the size of the shoe, I want to use enum. Why? Because some people's shoe size are 40, size 60, size 70. This is very big. Then I also want the option of small or large, maybe for children or adults. It depends on the brand. Then I come here and say insert into shoe. These are the column I want you to insert into. This column and this column. What value? I say for the brand name, this first one is what? Terima. This is just a feature's name. Instead for me to put a new value here, I will pick from here. So I pick from the list that is already defined, not new one, the defined one. You see, this is another entry. I say, okay, the brand name is Zara, size 70. The size I have available is 70. I said the other one is Bata. I don't know if I'm correct on this name. Then the size was small. I am only permitted to pick my size from here. I mean, this column, when I'm filling it, anything I'm picking from it must come from this list. Look at the one we had before. For instance, this. You see the name of the student, the email. These are the two columns. You want to insert into name and email. The value are Peter. This one is what? pet@gmail.com. You see that these are new to the system. They are not here. These two are not here. But for enum, you must take from enum list, which you have predefined while creating what the table. So at entering of these data, you must pick for what you have already predefined. Otherwise, it cannot go. Hope you understand what this one does. It's for list of what? Items you want to include in your table, but must be predefined while you are creating the table. Hope this is understood. Thank you. Now let's look at set. One of the type of string data type. A set is a string of objects that can have 0 or more value. It's like what? Enum. Just that enum start with what? Start with 1. But for set, it can start from 0. Okay? The best way to understand this, let me show you in this place. Look at this. I say create table, competition. They are say participant set. Remember enum, I give a list of string. Here, the same thing. It means that whatever I'm going to do for participant column, they must come from here when I'm inserting datas. I say we have the team column, we have the scores column. It's like a team having competition with another team. We have the list of all the participants mixed together. Then other displays now say insert. Let me reduce the size. We say insert into competition. Then this column, this column, this column, which is this, the values. Then you can see that for this participant, which is this one, because it was defined as a set, we must pick whatever we want to pick from here, which is for the participant. Then for the team, we say team A. Then the scores they had was 10. The same thing for this team B, we only have Mike. Take it from here. Team C have Tim and Dan. Now let's drop this one here. Let's see. Gone. Now let's see what we have. See. Participant. Eric and John, they are team A, they had 10. Mike, who was alone in team B, had 14. Tim and Dan has 20, which is team C. But the point is that all these participants, their columns must come from here because we define it as set. Assume we want to put another one, for instance. I just want to try something. This time I want to put just only one. I will put this time only Dan, for instance. Let Dan try. I will put Dan, only Dan in group D. But I will not say Dan. I will say Daniel. But I know that Daniel is not here. If I click this, see, it's giving me error because this first column was defined as a set and it's not here. Let me put Ben. Ben is not here at all. So let's see if it will accept. Still, it refused because it's not here. If I put John here now, just John, definitely it will go because John is part of the set. Mean it has gone. If I check now, you see, John is there. This is how to use set if you want to use this type of data type. Hope you understand this. Thank you for viewing. Now let's look at date and time data types. The first one on the list is the date. It's always in this format. The year first, followed by the month, followed by the day. And it starts from this to so this is the range it covers from this year to this year. Currently, you can see we are in 2020, right? So this 99. Okay, like this. Hour first, followed by the minute, then followed by the seconds. And the supported range is from minus 838.59 to 59 to 838.59 to 59. This is the rate for the negative to positive side. This one leads us to the date time. Here you combine both date and time together. That is the year first, followed by the month, followed by the day. Then you go down to the time. So this is the format of this one, the date time. And the range is to 59. This is the range for this. I will say that. Let's now go for the timestamp. This time is stored as number of seconds. The timestamp also have what? The same format with date time. That is and also the time part. Okay, but if you look at your system, the time in your system, your computer uses what? Timestamp. Okay, so this one is the one that you can change by yourself, turn around. But ideally, this one is what? System control or system generated. For instance, if you change your time zone, it can affect your timestamp, because your timestamp is the current time that is showing on your computer has to do with what? Your timestamp. Okay? So it is stored as a numeric value internally. Okay? So there's no more different that this one is the one that is controlled by you most of the time. You can change this one where you are inputting it. This one should be system based. And when you change your time zone, definitely it is going to affect your timestamp. Okay? Now let's look at the year. For the year, it is 4-digit format. The value of the year starts from 1901 to 2155. So the year is in 4-digit format. Values allowed in 4-digit format are 1901 to 2155 and 4 zeros. Okay? But what you should know is that from my SQL 8.0, 2-digit year format is not supported. Okay? This a new table we are going to create. With this SQL query, we are going to create a new table. Let's run this. Entered. So now, how do we insert data? This is the first thing you need to do. Say insert into. Then, where do you want to insert the data into? You mention what? The name of the table, which is this. Okay. One thing I want to see here now is you do what? Open bracket, close bracket. Then you call the name of the feed. The first one, followed by the second one, followed by the third one. This to let the system know that these are the feeds or columns I want to insert this data into. Then these are the values according to the data types. This is an integer. You insert this. This is a voucher. You insert this. And this is also voucher. So we are going to run this now to see the result. Inserted. Now let's check what we have. We're going to say select all from customers _1. Then we run it. Look at it. What we just inserted. This is one variation. We're going to insert another role into the same table. This time we are going to remove all these names. Instead of giving the name of the columns, we're going to remove them. Then you see what happened. Let's see if the system will be able to map it accordingly. The first feed, second feed, third feed, without giving the names of the feeds. Let's run it. Gone. So now let's go back again and check what we have now. See, the system was able to insert the second row without even telling the system the name of the feed. Okay, now let's go on. There's no difference between this one and the first one. But what I want you to learn is, in case, for instance, you want to insert multiple rows at the same time, you can just repeat this line several times. Like here, we just repeated it twice. See, 1, 2. Can make it 1,000, 10,000, 1 million. I drop it. Okay. So what we are going to do now, following this first method, we want to insert 2 new rows. We select and just run. Now let's go back and check what we have now. You see, the system was able to add this and this that are coming from these multiple lines. Okay. I want to see another variation. I want to follow the same method. Okay. To do this. But this time, we are not going to repeat each of the line, like repeating this very one. We don't want to repeat this one. We want to stop at this point. That is the only thing we need to do. Every other thing will be a duplicate. Every other thing will be what? Repetition of what? Just value. Just to insert value. See? First row, second row, third row. Without even telling the system about it. At this time, we don't need a semicolon here. We just need a comma. We don't need a semicolon here. We need a comma. Just like that. Let's see if this one will go. Okay, there's a 13 here already. I don't want it to be like this. Let me make it now 16. It will be 16, 17, 18. So let me change this name to Daniel. Let's just make this one 16th Street. Okay, I'm going to hit it now. Let's see. Okay, let's go back again. I run. Let's see what we have now. If we run this, we see what? Multiple lines have what? Entered. Remember what we just did? This one, if you want to do it, you have time to type. You type it out. You type it out again. You do the same thing again. But this I will say no. We just want to type only one. Then what? Repeat what? The value. Separate each of the row with a comma. The final one with what? With a semicolon. But here, each of them must be what? Separated with what? Semicolon. Now, I will say that, what if we don't want to include this? Assume we don't even want to type this. We want to follow this second method. How are we going to do it? This time now, we avoid anything that has to do with mentioning the name of the columns. What we did, we simply what? Say insert into the table the values. So let's make this one 19. Let's watch out for 19, 20, 21. Let's run this. Now let's now check what we have. Select. Okay, 19 to 21. See, 19 to 21. See, various methods. We are still achieving the same thing, but we are using what? Different methods. Okay, finally, let's do something funny. What is this thing that is funny we want to do? We now understand the various methods. The first one we did was everything was mentioned. This one, we avoid the name of the field. We achieve the same thing. We follow this first method for multiple rows. Okay. Then we still follow this method. This time, we avoid repeating this one for it. Using comma, comma, a semicolon without including this. Then we went ahead and did something else, whereby we avoid this one completely. We achieve this. But this time, what I want to do, I want to come back to this query. We're going to call this one now. Let's follow this method first. Let's call this one 22. Let's say 22 Street. Let's call this one what? Bat. Okay. What I want you to see is that I want to remove this. Okay. Remove this. Also remove this, which is okay. But let's see what the system will do. It's supposed to be 3 feet, but we are giving what? 2 feet. Look at, let's see the result. See, column does not match. Column does not what? Match. Okay, what we remove now, let's go back now. I remove only this because it's the one that is missing here. Because it's missing, let's now measure the name of the field and remove this. Let's run it again. Now it allowed. Why? Because if you are going to avoid or omit any of this field, you have to use this. You can't use different method like this one, like this method, and decide to what? Omit any of the value. Okay? If you want to omit any of the value, you must tell the system the exact one you want to impute this one into. And if you check now, you find that what? The system recognizes what you've just done, that this one is null. Alternatively, you can follow the same method. Okay? If you don't want to put this now, you can do something by saying, okay, here is what? Comma. Then you make this one what? Empty. Then let's make this one 23. Let's call it 23 Street. Let's run it now. It still went. Let's check. You found that there's nothing evil here. Not even null. Okay, good. What if altogether I want to put a null value here? Assume it's actually null I want to put. You can do that. Run it. There's 23 already there. Let's now use 24. Let's call this one 24th Street. Let's watch out for 24th Street. Now let's check 24th Street. See, no value. Two ways now. Either you indicate it or you do something like this. Okay? At this junction, I believe you understand the process. It depends on the one that is convenient for you. All you have to do is continue to practice. Hope you understand this. Let's go straight to the next class. What's a candidate key? The word candidate means that you are ready for something. When you are ready to do something, like you are ready to write an exam or you are registered for an exam, it means you are qualified for that exam. So qualification. So any key that is candidate key is qualified to be a primary key. Where you are a qualified key, you are a candidate key. That means we can use you to do something. We can use you as a key. You have potential. You have the ability to become a key. You have the characteristics. You have the features. Let's look at this. For a column to be considered as a key, it must have unique identity, mean non-repetitive characteristics. If you look at this table very well, this is 101, 102. You see that nothing is repetitive here, and everything is what? Is unique. Each line, each row, they are all unique. So we can consider this one now as what? A key. No two cars can have the same number. So car number is also what? A potential key. First name is out of fit because two people can bear same name. Two people can bear what? Same name. Even the last name is out of fit. You can see this one, Victor and Victor here. Two people can bear the same last name, like brothers, sisters. They can bear the same last name. Another thing that I see that is unique here is the email. The email is what? Unique because two people cannot have the same email. Because all these are all unique, we say what? They have potential to become key. Therefore, they are all candidate keys. They are all what? Candidate keys. This is a candidate key. This one is a candidate key. This one too is also what? A candidate key. You can see, they are all candidate keys. Also, let's look at this one. Staff ID. No two staff can have the same ID. So I will call this one too a candidate key. But this repetitive, this column cannot be considered as a key. This one too, first name, two people can have the same first name. The same thing with this one, two people too can have the same last name. So the only key that is here now, that is have the capacity or the capability to become either primary key, whatever key, is what? Is staff ID. So we can say what is a candidate.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
And this table, as you can see here, is shift for different staffs of a company. For instance, working in an hotel. And you agree with me that time is not steady. It's too complex to use as what? As a key. When do we need a surrogate key? Like this example before us now. This name can never be a key because it's not steady. It's always changing. Three people can be called Sue. The same thing with surname. And you agree with me that this number is too complicated. A time is coming, maybe tomorrow or by this time next week, there will be another 5 p.m. here. This table comes without any key. Remember what we are considering of this table now, that the professor, every professor have ID. It's not something that you formulate. It's normal for professor to have what? ID. It's normal for students to have ID. This is a normal thing to do. It's normal for staff to have ID. It's normal for your car to have a unique number. Here, this table comes without any unique identifier. You have to manually generate it. You cannot call it, or let's assume okay, it's a serial number. This serial number now, you are using here now, is a surrogate key. This serial number will never change. It will continue like this till 1 million to 1 billion. It's therefore called what? Surrogate key. A surrogate key is a key that is faultless. It doesn't have any connection with the table. If you remove it from the table, it does not affect the table. But you are attaching it to the table because it will assist the table to be able to sort the rows that are what? In different what? Places. What's a primary key? The first thing we must consider to say you are a primary key, all the values in that columns, they must be all unique. That means there should not be anything like what? Duplicate or repetition of value in that particular column. This is a table of students. And we agree that without being told anymore, with what we have learned so far, this is considered what? As a candidate key, another candidate key. So this cannot be considered as candidate key, these two. No, these are not candidate key. They don't have the characteristics to become key. Out of these two candidate key, we pick one primary key. You have to pick it. So if we agreed now that this column is our primary key, what will be the name of this one? This one that is not choosy becomes what? The alternative or secondary key. This becomes what? The alternative or secondary key. You have two keys that are what? Candidate key. You pick one as primary key. The remaining one becomes what? Alternative or secondary key. The same thing with this table now. Is only this one I consider as what? The only key that is here, that has the characteristics to become a key, that have the feature of a key. So it's a candidate key. So for this table, this will be our primary key. If we choose this one as the primary key, we don't have any other key here. So we cannot say, well, this is a secondary key or no. It only has what primary key. These students, they all register for exam. They are about to write exam. These are their exam numbers. This is the table they are meant to sit. This is their names. This is their email addresses. This one is a candidate key because they are all unique. Okay. This is also a candidate key because it's so unique. This column 2 is also a candidate key because it's unique. But what would be the primary key now? The primary key, you have to choose the primary key. You could call this one the primary key, this one the primary key, or this one the primary key. But let's choose this one as what? Our primary key. This column. Let's say this column now. Let's use another color for it. Let's say it's our what? Primary key. This is our primary key. Now, what is this key called alternative key or secondary key? This one simply means this is a table, for instance. This is a column A, this column B, this column C, this column D. After checking, we found that this one has unique ID and it's not repetitive. This one also has unique ID, not repetitive. This one has unique ID, not repetitive. Then we decide to say code B is not the primary key. You can also decide to say code D is a primary key. If this is your primary key, the remaining candidate key are called alternative keys. You have many keys. One is a primary key. The remaining one is what? Alternative or secondary key. Foreign key. key. For you to be a foreigner, you must be existing somewhere before you came to my country. If you come to my country and I look at you, I say, where are you from? You say you are from India, or you are from US. You are from USA? Or you say you are from India. Or you say you are from Ghana. Okay? As far as you are concerned, in my country, when you come to my country, you are a foreigner. It means that what? You have a passport of another country. This table, for instance, this is the primary key of this table. For this table too, this is also the primary key. This is also the primary key of this table. Now, in this table, you see very well, this is a table of students in a particular school. This guy, which is the supervisor, want to access the table, want to associate with the table, want to befriend the table. If you take this one now, for instance, and make provision here, for instance, to bring it in, like, for instance, we say the supervisor of James is Professor Mike. You put 3023 to represent Professor Mike in student table, in this student table. As far as this is concerned, in this table, because it's already existing in another table, because it exists in another table before now. If you carry it to another table, it's not a foreigner, it's not a foreign key. Remember, it's a local key here. You brought it here to become what? A foreigner. Which what? A foreign key we are talking about. Look at this place now. This is what we just did. What I wanted to do here, I've done it here already because I don't want to waste any time. This guy was not here before. If I bring it in, meaning column, which we are using to represent the professors or the supervisor. This column we are using to represent the supervisor in the student table. They were local here before you move here to identify the student whom what they are supervising. Because this column was existing somewhere before, it was a local key in another table, which is a primary key in another table. You are now bringing it here so as to associate the professor or to associate the doctor, to associate the dean with the student. This one become what? A foreign key. Why this one still remain what? A local key. If you have moved this student ID to this supervisor table, automatically this will become foreigner here, which is foreign. Pardon me for saying foreigner because I want you to understand it. But here is local, is a local key, or call it what? The primary key. It has as a cross-reference between two tables. So this one now is acting as a cross-reference between this table. You must also know that what? The purpose of a foreign key is to maintain data integrity. To maintain what? Data what? Integrity. Data integrity. Another thing you must know is that what? To allow navigation between two different instances of an entity. Two different instances of an entity. A foreign key will allow you to do that. So the concept is known as referral integrity. Why? Because you are using this one now to refer to this one. It's called what? Referral what? Integrity. How would you define a primary key? What we learn? How to define a primary key constraint in create table. Look at this. I want us to create 3 users with the same column names. Username, password. Username, password. Username, password. Okay? The only difference you can see here is I choose this one as my primary key. the type of data is integer. I said this is the primary key. This is how to define it. This is my what? Primary key. But that primary key, I say what? Not null. Alternative to this is auto increment. Auto increment means that the system will be auto incrementing this number. When you insert a new record, it will generate automatically a unique number. But if I don't want to do that, I want to manually put in my ID. What I will need to do to make sure that this still comes in, because it's very important, is to say what? Not null. But this is what I'm looking at now. Primary key. Defining it what? The same line. For this user 2, which contains the same column's name, I did not define the primary key here. What I did is I simply use a different line to define the primary key. I've set all this one. Then I went for that to say, okay, among these three, I am choosing this one as my primary key. That means after dropping everything, then you now go ahead and still tell the system, this is my primary key among this group. But what if you have two primary keys you want to define? Now I want to use these two as primary keys. These two will be my what? Primary keys. I can still do the same thing. So say, okay, primary key, then I choose this and this as my primary key. I've done that. I want to use one body to run everything. I run it. Everything is in. Now let me describe from user 1. Look at what it's saying. The primary key is this, and you can't make any of them what? Empty or blank. Everything must have what? A unique what? Number. The next one is 2. If I run 2, I have what? Same. Remember, different methods were used to create this what? Primary keys. This one, same line, a different line. Let's look at 3. 3 has 2 primary keys. See, this and this, this and this. Hope this is understood. So if you want to create even 3, assume I want to use the password, which is not necessary, just for practice purpose, I can put it here. Then I change this name to 4, for instance. Can still make this one. Then I put here 4 to check. If I check, you will see that now all the 3 are what? Primary keys. Hope this was well understood. Let's move straight to the next class. How would you delete a primary key? This was the query we used to create the various sorts tables with these keys. If you want to drop this primary key, you don't want it to be here again, what do? You have to tell the system that you want to alter the table. That means you are altering it. That means after you must have performed your action, it will not be the same thing as it was before you what? Perform this action. That is the meaning of what? Alter. So you say alter table. What is the table? The reason why you must specify the name of the table, because there are many tables in the database. So I will say it's users 1. Tell the system what you want to do. I want to drop primary key. That is all. I want to drop the primary key in this table. So let's run this. When I run it, succeeded. Let me go and check. You see no more primary key. Okay, that's okay. Now let's take the same thing. Let's copy the same thing. Come here this time. But at this time, we are going to use user 2. That's the name of the new table. But let's first of all see how it looks before we run this. I will find out what there's a primary key here. So now let's drop it. When you drop, now let's check. You see, there's no more what? Primary key. Let's also try the same thing for this one with 2 primary keys. Okay, let's use user 3 here. Now let's see if everything is gone. Okay, it's user 3. Let's say user 3, not user 2. See, the two primary keys are removed. So whenever you want to drop a primary key, simply tell us the name of the table you want to alter, then you tell us what you want to drop the primary key. Hope this was well understood. Let's go straight to the next class. Is it possible to select a primary key after a table has been created? What you will learn here is adding a primary key to existing table. Look at this. This is a new table with 3 columns: person ID, person name, person address. We're going to create this table now without this primary key statement. It means we are creating this without what? A primary key. Now let's describe this table. If we run this, you find that there is no primary key anywhere. So now this table is created. We want to add what? A primary key to it now. How would you do that? All you have to do, you say alter. That means you want to change the structure of the table. What is the name of the table? Say persons. What do you want to do? I want to add a primary key to this table. What is the name of the column? I want to use this. Then I drop it here. That is all. I'm going to run that line now. Accepted. Then I go ahead again. Still run it again to see if it has been added. See, it has been added. So it is possible to add a primary key or to select a primary key after the table has been what? Created. Hope this is well understood. Let's go straight to the next class. How would you assign a foreign key in create table? What you will learn: assigning foreign key. Let's see. This is one table. This is another table. This is the first table that need to be generated first before you can create this table. I look at this table like the primary table. Why? In this table, we want to assign a foreign key. How? For instance, you are a citizen of India. You decide to travel to Canada. When you arrive in Canada, you are now what? A foreigner. Why are you a foreigner here? What qualifies you to be called a foreigner? Because you were local in another country before. So while you are here, we call you what? A local. But while you are here, we call you what? A foreigner. You can see this place. It's already a primary key. Look at this as local. On arrival in this place, it becomes what? Foreign key. Look at it like a foreigner. Okay. Now, a column that is not existing cannot be assigned either with foreign key or primary key. You can see this column mentioned first before we can call upon it to become the primary key, to become the king of this table. So for you to call this one a foreign key, you must create this first before you what? Reference it. Why? If you just leave it like this, you cannot create it. Because if you do it like this, the system doesn't know what you are referring to. Before that, let's see. I have not created anything yet. I want to create this one for the first time. Let's see if it will allow us to go. If I click this, it's telling me fail. Why? Because it says what? These customers fail to open reference table customers. Unless you are existing somewhere, we can't call upon you. So we need to first of all create where the primary key is located before we can create the foreign key that is referencing it. So let's create this one first. Accepted. Now, first of all, now let me remove this one to see if I can do without it first. Can I just call upon a column as reference key without first mentioning it under this place. Let's see. If I click this one now, it's giving me error. Say customer ID does not exist. So let me go back. I put it now. If I put it now, it will now allow me what to reference it here. I remember this is a syntax foreign key. Who is the foreign key? You say this very one is the foreign key. Okay. Where is it located? That is the meaning of this. Where is it located? I am referencing it in this location, which is this place. And when you come to this place, please attach it to this one. Okay. What I mean is, this is the one I am electing as my foreign key. Oh, the system is asking you, for you to make this one the foreign key, it must exist somewhere. Can you tell me the table where it's existing? Because there might be many tables in this database. It's okay. This is a table. That is this table. Okay, if I arrive in this table, which of the column is this column? If you do it like this, it will accept. See, accepted. The next thing now is, I want to go ahead. Instead of, first of all, imputing any data here, that is inserting any data here, I want to first of all try to insert data here. Let's see what happened. This is what I want to put. What am I putting? That's okay. This is for this. This is for this. This is for this. Can it go? Let's see. Error. What is the error? It says, well, cannot add or update a child role. Why? Because before you can update or insert into a foreign key, it must reference what? The primary key. Because it's referencing the primary key, if you are trying to add this, and this is not even in existence, this value, because it's the last one here, which is the foreign key. If it does not have similar value here, it will not work. What I will do now, I will come here to insert this value for customers. Accept. Remember, the primary key is 10. So if I want to use this one now, I must use exactly 10. That is 1, 2, 3. The third one. That's 1, 2, 3. It means among all of them, it's only this one that will go. So before we do this, let's try if this one will go. Because this place is 202. But the only value that is available here is 10. If we do this to check what is available here, we find that it is just what? 10. So it must reference this time before you can insert anything for this foreign key. You see, it failed. Even though if you try this, assume you try this, it will not still go because the only thing that is available here is what? Is 10. So let's try this too. Fail too. It's only this one because 10 is already waiting. So I want to use this 10 as my foreign key because this is a foreign key, which is this, and it's already inserted in the primary key. This is the only way it can go. You see, it has gone. Let me select for others. Now, other has something now. This one is here. This one is here. This one is here. These values has to be accepted. If you don't do it like this, it will not work. The primary side must be what? Settled before you come to the what? The foreign side. Hope you understand what we are doing. Thank you for viewing. How would you assign a foreign key to a table by defining the constraint explicitly while creating the table? That's what we want to learn here. Let's see. This time, we are still using the same method. I just call it K, just to distinguish these tables from every other table. Just name difference. Normally, we first of all run this. Okay. Then we will run this. But if you can see here now, there's no constraint defined. We are asking the system to help us choose a constraint, which sometimes is not okay. So if I want to define a constraint name by myself without allowing the system to do it for me, I will simply come to this place. Before the foreign key, I will say constraint. Then I give the name of the constraint. I say like foreign key underscore customer ID. You understand? So this is the name of the constraint now. That's what we are defining. If you don't do this thing, the system will auto-generate a constraint for this foreign key. This is the only difference. And if we run this now, we have what? Our solution. So let's run this. Gone. Now let's describe this table to make sure that what we are saying is true. Orders K. Let's see orders K. You can see it is defined. If you now want to know the constraint now, just say show create table, then you give the name of the table, orders K. Then let's run it now. Let's copy this to see clearly. Where we copy, we found that the constraint assigned is our constraint, not the system auto-generated constraint. If you want to see how that one is, which I know you should know by now, let me just do another one. I will call this one orders P, orders V. Okay. Then I will remove this constraint. Let the system define this one for me, so that you can see the difference. I've done the same thing. Now let me say orders V. Let's see orders V. If we copy this, we find that though we did not assign this constraint by ourselves, this is what the system assigned, because the system must still put a constraint, but it will generate it automatically. For our own, we did. It was the name we assigned, a foreign key, customer ID. That is what given to it. Hope you understand this. Thank you for viewing. How would you add a foreign key to existing table? What you will learn in this session is how to add a foreign key to already existing table. Let's see. In order to avoid confusion, I went ahead and copied exactly the same query we used to create the customer and the orders table. So what I want to do now is I will put 2 here. I also put 2 here to make it what? Entirely 2 different tables. Here, we are creating the foreign key from the offset, but I want to remove this. Assume I have not decided. I will change this one to customer 22, this one to order 22. Now, I want to create this without a foreign key or this without a foreign key. If I run this, accepted. Okay. I'm going to run this too. Accept. So let's check the 2 tables and see what it shows. Describe orders 22. Also describe customer 22. Now let's run this. We have primary key, but there's no foreign key. Let me see this one. No foreign key. This is an existing table already created. How do I add a foreign key? Assume I've decided. Before I did not decide, but now I've decided that this particular customer ID is going to be my what? Foreign key here. Okay. What I will do is I will simply say alter table. What is the table name? Order 22. Now what do you want to do? I want to add foreign key. Okay. If you want to add a foreign key, so what is the name of the key? I simply say the name of the key is customer ID. Same name, same name. Let me run this. See? Now let me run this to see what is showing me now. Now it's there. This is not the foreign key. Hope this is understood. Again, these tables were created without what? Any foreign key. To do it, you alter the very table. You add what? The foreign key by calling this particular column, which is this. Then what? You assign what? The very reference to the table. Once you do this, you are true. Hope you understand this. Thank you for viewing. How would you add a foreign key to a table? By defining the constraint explicitly while adding the foreign key to the table. Here we are going to add a foreign key. While we are adding it to existing table, then we define the foreign key and the constraint together. You are familiar with these 2 queries. I want to use them to do this work. Here I will put Z. I'm going to put Z here too. I will run this. Okay. I don't want to run this. I want to do this without what? Any foreign key. so that we can be able to demonstrate how to add a foreign key to it with a constraint. I've done that now. Now let's describe customer Z. Let's run. Yeah, it's in the system and this is the primary key. Let's also check for order Z. Order Z is there without what? The foreign key. Let's try to add a foreign key now with a constraint. Say order tables. What is the name of the table? Order Z. What do you want to do? I want to add a constraint first. That's the constraint name. What is the name I want to add? I will say okay, is foreign key underscore customers. The next one now is the foreign key. What is the column you want to use? I want to use the customer ID. In what table? I'm referencing the customers table. Then I say customer ID. Here this author. We alter the table to add a constraint name, then also the normal foreign key. Okay, let's run this. Okay, sorry, here we're supposed to put the Z because correctly this is now Z. We put Z here. Let's run this. It's gone. Now let's go back and what? I check what we have now. We now have what? A foreign key. Also, let's check show create table. And the name of this table is orders Z. To see the constraint name, I'm going to copy this. Let's check. What is now your constraint name? Constraint this, which is the same thing with what we what? Explicitly what? Defined. Hope you understand this. Let's go straight to the next class. How would you delete? How would you delete a table whose column is referenced by another table in primary foreign key relationship? What you will learn here is deleting the reference table. I'm sure you remember these two tables. Let's see. This one is here. And if we describe it, you will find that what is still in the system. Even orders is still in the system. And this is the foreign key. What I want to do now, I want to delete the customers. Look at the error. You say what? Cannot drop customer. Cannot drop table customers referenced by foreign constraint. This. So there's a constraint on it. Okay. So if you want to do this now, what do? The first thing you must do is, first of all, you have to delete this table before you can delete this. This is what I want you to know here. When you refresh something, it's like you have actually attached. This is the foreign side. This is the primary side. You attach this one to this place. There is no way you can delete this without deleting this one first. So the rule is you delete this one first before you can delete this. Because if you delete this, this one will be useless and the system was not designed to act like that. So all we have to do now is drop table orders. We delete the foreign key first to make sure that there's nothing attached to these customers. Okay. We drop this. Definitely drop. Before we cannot drop what? The customers. Everything is dropped now. We cannot go ahead to say show tables. Definitely there are tables, but there is no customers, there is no orders. Hope you understand this. First of all, you delete the table that contains the foreign key before you delete the one that contains the primary key, which the foreign side is what? Referred to. How would you delete a column of a table? What you will learn is deleting a table's column. Let's first of all run this to table that is in. Let's run this to that is in. Now, if I want to delete, say this column, how can I delete it? That is why we are here. To delete it, same author, because we want to alter the structure of the table. You give the name of the table, which is customers. You say drop column, because you are interested in what? In dropping a column. What is the name of the column you want to drop? I want to drop this. Then this. Let's run it. Okay, now let's see the structure of this column if this is still there. And to do that, we simply say what? Describe customers. If we run it, we find that it has disappeared. So let this and this that are remaining. This one is gone. How would you delete a reference column of a table? What we will learn is deleting a reference column. You look at this, we are going to run them again. Run this again. Now let's check both tables. This time we are using PP and PP just to distinguish them. Let's describe others PP. See, this is a reference column we want to delete. So how do you delete it? You have to first remove the constraint because a foreign key is a constraint. Unless you remove it, you can't delete what? The column which it is acting upon. So what we do first, we try to delete it. We're going to say author table. What is the name of the table? Others PP. What do you want to do? I say drop column. What is the name of the column? Customer ID. Let's run this. See, it's not allowed. The first thing you must do is you first of all remove this reference by say authors table, name of the table. What do you want to do? Drop foreign key. What's the name of the foreign key? We don't know. Because it's not this, it's not this. We need to pick the reference what? Name. That is the constraint name. We need to pick the constraint name. Because foreign key are constraint. So we need to know the constraint name. And to know the constraint name, all we can do to know the constraint name, let me go down, is to say show create table order PP. Why? Because this was what I used to create this table. If I remove this, it's like I'm about to create a new table. This one will show me what you used to create this table. If I run this now, I should be able to know the auto-generated constraint name, which I didn't put myself, because when you are doing this, either you manually define the constraint or the system generate it for you if you don't put it. And this was the name the system used. So I'm going to copy this name now. I will come here to say, first of all, remove this constraint. Then I say this. Let's run this now. Allowed me. Now let me go back again and not delete it because I've removed the constraint on top of this column. Now I want to delete the column now. Let's see if it will go. This is it. Let's run. See? Accepted. Now let's go ahead and describe the table to see if it is still there. You see, it has gone. No more foreign key. Hope you understand the step. Thank you for viewing. Write a query to show all columns and rows in employees table. What this is testing us is to see if we understand the meaning of all rows and all columns. In SQL, asterisk means all rows and all columns. So when you are selecting it, you are selecting all rows and all columns. Nothing will be left behind. I'll select all rows and all columns from this table. That is exactly what it has done. The last name, the first name, the title of courtesy, birthday, hire date, address, city, region, postal code, country, own phone, extension note, report, photo parts, salary. We can also investigate for shippers. We are not asked to do this, but let's just see. This is everything. All rows are now columns in shippers table. What about orders? You see, these are all the rows. See, these are the rows going down, and these are all the columns. We also have customers. These are all the rows, and these are all the columns. So this is the reason why we are here, and I hope this was also your output. Let's move straight to the next challenge. Select only the following specific columns from employees table: employee ID, first name, last name, and salary. Before, you selected everything, but now we are asked to select specific columns. How do you do that? Say select what you are asked to select: ID, first name, last name, and salary from employee table. You see, now we are being specific. You can select all the columns sometime, but apply your asterisk. Mean you are not specific, you want to do everything. But if you are meant to select specific columns, you can follow this method by what? Specifying what? The name of the columns. So I hope this was also your output. Let's go straight to the next challenge. Your manager wants to see all the details of the company's customers. That was a typical question a layman can ask you. I will explain this extensively. There is no need to talk about anything rather than go straight to the solution. This is what the manager wants to see. You just print it and send to him, or you call him over to come and see. And hope this is exactly what you did. Let's go straight to the next challenge. You sent the above result to your manager, but asks you to streamline the result to company name, contact name, and address. This is what your manager wants to see. He doesn't want to see all the columns as we did in the previous instance. The company name, the contact name, and the address. The company name field in customers table contains the customer's name. Get the list of customer with a new title, customer name or customer name. One is either customer name separate or joined together customer name. This question is to introduce Alliance to you. Alliance in MySQL is used to change the title of columns or fields. Instead of the original title or a new title generated by the system, you insist or you enforced a new title on the system. Company name from customers. We are talking about this. This is company name as written on this column. These are the company that we are servicing. So we should call them what? Customer names. Question is, instead of these, change this to what? Customer names. So all you need to do, immediately after the field you are targeting, you use as. As mean return it with a new title. And the question says we should return it as customer name. Customer name. But what is remaining? Because of the space here, the system will give you error. Therefore, you have to put it either inside single quote or double quote. If we return it now, it's now what? Customer name. The question also says you can also leave it as customer name joined together. If it's a one word like this, just one word, there is no need for single or double quote. You still have a result returned without error. But if you decide to put it, there is no problem. You still have it. And also what you should know is that I can also decide not to put this at all. The system knows that once there is a feed and there is no comma, you put something that is not a feed, that's not a column, immediately after something that is a column. Therefore, you are trying to generate what? Alias. So it will still allow you. If you want to still put a space in between, it will still allow you. If there's no space, you want to remove this, to still allow you. One is a space with this, and there is as, a space with a single quote without as, no space with quotation mark without as, no space as, quotation mark, no space as, the value here. See? To allow you. You can even go further, okay? The next one I want to do now, customer ID, if I choose to. Without anything, it will still give it to me. But once I put something like this, let me just do something rubbish. It will change it without even putting anything in between this place. But if I decide to put it, it will still give me the correct result. But if I put a space here now, if I do it, it will give me error. There's error now. So therefore, you put single quote or double quote. You can also put double quote, but preferably single quote is good. It's allowed. Calculate the following and return the results with the corresponding headers. So the first one says 20 plus 50 plus 30. So select 20 plus 50 plus 30. If you leave it like this, you have this header, which we don't want. So I have to say addition. You can see this, I did not put anything here as, because the system will allow it. Or I can also put as here if I want. The header has been changed. That is the first one. The second one says what? I should change, I should calculate this one too. 20 multiplied by 100. And this should be what? Multiplication. So here now it's now multiplication. You can also remove this. There is no problem. Okay. The next one says 10 divided by 2, which is 5. You have to say as division. See, it's not division. You can also remove this, no problem. You can still put this, no problem. The final one says 5 modulus 2. Modulus means the remainder. If you divide 5 by 2, what is the remainder? We know the remainder is 1. It's 1. But the header is not what we want. We want to see what? Modulus. So, or as modulus, or you still put this, but depends on you. Modulus calculation, for instance. Hope all these were your results. Let's move straight to the next challenge. Write a query to join hello and word to become hello world. This challenge wants to introduce to you how to use concat. Concant is used to combine string together. Can be 1 string, 2 string, 3 string. Because there is a space between hello and word, I can put the space here. See, we have this. Or I can decide to put the space before the word. Still the same hello word. What if I don't want to put it either of them? I can also create it here to say another string, but it's a space string. So this one will provide me this space. Let's see. Still the same. Concant is used to combine string together. Write a query to combine I love SQL query to have I love SQL query. You see, I'm putting space at the front of each. I don't need this last one because it is the last string. See the solution. I love SQL query. Hope this was also your solution. Let's move straight to the next challenge. Write a query to generate full name by combining first name and last name fields from employees table. Simply say select concat first name, the last name. You can see we are not putting this inside quote, because if you do this, it converts this to what? Ordinary string. But we are referring to the field or the columns of employee table. Employees. But the thing you should know now, there's no space because we cannot join the two names together. Okay, let's just return this first and see what I'm saying. You can see that everything is what? Joined together. This is not the desire. And there's no way we can put space here now to have the same. Still not correct because this is not a string. So all you have to do, you generate the space artificially with this. So there's a space here now, which is a string. The reason why we are putting this single quote. So now there's a space between this and this. And if you want to confirm, we can just simply pick these ones and drop it before this. Then we remove this to verify that we are correct. So this is what we are talking about. This and this combined together to have this. And there's a space between them. And if you want to change this header, you can simply come here and change this one to as full name. Then you put single or double quote. So this one has changed to what? Full name. You can as well remove this if you don't want it. Full name. Let's go back and remove this to have our solution. Hope this was also your solution. Let's now move straight to the next challenge. In a layman's term, explain what order by does. What order by does. Order by. If you have a set of numbers like 3, 1, 2, 1, 4, 6. Order by, as the word goes, to order something, to arrange them. It could be when you apply order by, this number will be arranged either 1, 1, 2, 3, 4, 6, or 6, 4, 3, 2, 1, 1. This is from the smallest to what? The largest number. Why this is what? From the largest to the smallest number. And this is what we call what? Ascending. Meaning what? It's moving what? From the smallest to the biggest. Why this one to what? Descending. If we apply this with this, we have this from here. This is the input. We have this. And if we apply this with this, we have this as our output. So order by helps us to arrange things according to their value, the weight of the value, what comes first before the next one. By default, all order by, if you don't apply this, for instance, you don't apply this, by default is ascending from the smallest to the biggest. But if you want to force it, say I want to force it to be what I want it to be, you cannot apply either ascending or descending. Okay. Also, if you have something like this, A, B, D, Q, L, for instance, if this is the input, okay, when you apply order by ascending, it means A will come first, followed by B, followed by D, followed by L, followed by Q. This is what? Ascending with order by. But if you want it to be descending, it will go from the last to the first. This is how it goes. The same thing goes for, you have things like hello, Peter, and you apply order by on this. If it is ascending, and will come first. This ascending, followed by hello, followed by what? Peter. If you apply descending, Peter will come first, then followed by hello, then followed by what? And. So it depends on how you want to arrange them, descending or ascending, with order by. You are just arranging, which you can also call what? Sorting. You are sorting them according to the weight of the values. Hope you understand this. Thank you for viewing. A customer needs the price list of your products. Return the product names and unit prices with the cheapest product at the top and the most expensive product at the bottom of the list. What I'm going to use is the product name and the unit price. So you have to do something like this first. If you don't know the structure of your table, you do something like this before you pick the right field or the right column. So I will pick the first column here, the product name, also the unit price. Remember, MySQL is not case sensitive. You can use capital letter, you can miss it, doesn't matter. I will make this one capital letter. So it depends on your style. Okay, if I do something like this, I have not done the right thing, because the question says the most expensive product should be at the bottom, meaning we should use order by. So order by is what we are learning in this class. Order by will help you to arrange your value either in descending or in ascending order. But this one is telling us to do it what? In ascending order. And remember, you have to use one of the feed as a reference point. And it asks us to use what? The unit price, ascending. This is the cheapest and this is the most expensive. If you print this and give to the customer, you have what? Done the right thing. Hope this was also your solution. Let's move straight to the next challenge.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Your new HR manager wants you to print out the names as salaries of employees with the highest paid employee at the top and the lowest paid at the bottom of the list. This is simply asking you to use descending, for the biggest to the smallest, the reverse of what? Ascending. And it did not tell us to do anything. It's only interested in what? In the arrangement of what? Of the figure using the salary. So we are going to pick all the feed from employees. Order by, what are we using? They say we should use salary. Descending. And you look at it now, we did not use this one. That's why you see the employee ID is scattered. You can see the salary is arranged now. See? From the biggest to the smallest. And if you remove this, you are telling the system to work by itself. You are not instructing the system to do anything. So this first feed was used to do the arrangement, or instead of forcing salary to be the reference point. But once you put back this, then you have the salary arranged in descending order. Hope this was your solution. Let's move straight to the next challenge. Your new HR manager wants you to print out the names as salary of employees with the highest paid employee at the top and the lowest paid at the bottom of the list. She only needs the first name, last name as salary of each employee. Salary should be in this format, $, then the value formatted. Say select, need the first name, say first name, needs the last name, also need what? The salary from employees. Look at it now. Look at what we are having. This is not what the challenge asks us to do. This is not the challenge. This salary should be formatted. So let's put format here. Please note that this format is treated, but check the section of format to know how to use it. And it should be in 2 decimal place. See, it's coming out now. But this is not everything. You also want the $sign to be before this format. So we have to use concat. Also know that concat is treated too. The first thing we want to see is this, then before this. You understand? This concat is assisting us what? To put the $sign. Concat is already treated. Why this one will still remain the same, just as it is, but we still need to put what? The format. You see, this is what it's asking us. What it is missing is the highest paid employee must be at the top and the lowest paid must be what? At the bottom. So we have to now say order by salary descending. See exactly what the question asks us. From the biggest to the smallest. Hope this was also your solution. And you can see what I did. It's not that I cannot come straight to this point, but I just want to explain to you to break it down so that you understand each of the point. We're going to see a lot of things like this, combining a lot of formats. So if you have not done like concat, you will not be able to understand this. If you have not done format, you will not be able to understand it. That is why you shouldn't drop any of the classes. Make sure that you attend all the classes by watching all the videos. With that, you'll be able to combine the knowledge of concat, format, order by for other things. This is just the beginning. We are going to do a lot of this. Thank you. Our company wants to know those that are due by age for retirement. Please return all employees' details with the oldest first and the youngest last on the list. Okay. Order by birthday, because there's a column called birthday. If you check it first, you will see that we want to do this by what? By this column, birthday. So it should not be what? Ascending, because small number like this will be at the top, while 9060, 9066 will be at the bottom. And you agree with me that 9037 is older than 9066. Therefore, we have to use what? Ascending. This is what is expected of us to arrange according to age. So the oldest person is Margaret, followed by Nancy, then Andrew, Steve. With this, the company can detect who is due for retirement. Show us a list of any 10 orders from orders table. This is to introduce you to limits. Limits will help you to reduce the number of rows that is returned by SQL. All you have to do, simply select. No column was specified, so we can use the asterisk from orders. Then we have to put the limit. Limit what? Limit 10. Only 10 rows will be returned. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If this was not here, we have 830 rows without limit. But when you put limit 10, we have what? 10 rows. Hope this was your result. Let's go straight to the next challenge. Show us a list of 10 orders from orders table starting with the most recent orders. The most recent order, can find it with the help of order date. And this is 1996. 1998. You're going to use order by, order date. The most recent will be a bigger year, 1998. So you have to say descending. Limit 10. So the question or this exercise is trying to see if you understand how to combine the limit and order by. Let's see the solution. You see now? So this is the most recent. Because the question says starting with the most recent orders. And there should be 10. And if you count them, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hope this was also your solution. Let's move straight to the next challenge. Find the highest salary from employees table. Also show the names of the employee that is receiving this salary. To show the names of employee, you simply say the first name and the last name. From employee. Limit 1. This is the highest salary. The trick I use here now is, I know with this, I will order from the highest to the lowest. If I remove this, that's exactly what I'm getting here. But if I now put this limit, it's picking the first one. Limit 1. Janet is the person that's receiving the highest salary. Hope this was also your solution. Let's go straight to the next challenge. For instance, this employees table, we want to order by random. You see, just be looking at this to be changing, because random means what? No particular order. See, it's changing. So let's make it like limit 2. Okay, enter again. See, this is changing because we said order by random. Hope you understand this. Remember, this is not any of the column. If I say order by employee ID, for instance, strictly like this, it will remain the same. If I say descendee, it will remain the same. If I say ascendee, it will remain the same. But when I say order by random, which is not even in this table, it's a function, you can't control it. That is what it does. It's picking it randomly. Hope you understand this. Thank you for viewing. In MySQL or in SQL generally, we use comment every day. Once you use comment, it depends on the need. If you want to comment on your queries or your statements, you can use either single line comment or multi-line comment. So let's look at single line comment. If you want to use single line comment, you use 2 hyphen, you give a space. You must give a space. Or you use this hash, you give a space. If I type something here now, like I say select this from employee, you can see the color change because it's all comment. If I pull this one down here, see, this is a big mistake. So you must give that what space. If I remove it now, it's what? A query which I can run. Employees, which I can run, then I have this output. But if I put this without space, it will give me error because it doesn't know what I'm saying. But if I give a space here, it's not a comment. Even though I run it, it's just a comment. Okay, I will say that I can do the same thing with this hash. Look at it, it's a comment. It's a comment. You don't need a space here. Depends on what you want to do. You don't need the space where you are using the hash. But if you are using the hyphen, 2 hyphen, you must give a space between the 2 hyphen and the what? And the query. Okay, and also you know that you can also do something like this. For instance, okay, this is a query. Okay, this one we run definitely. Okay, this is a query. Or you come here, put 2, say this is a query. But if you don't give a space, error. If you give space, you are correct. If you want to put hash, you don't need a space. Okay, that is what single line. But if you want to do multi-line, all you need to do, let me come to a different line. If you want to do this, simply say / you put 2 asterisk in between to put your what? Your multi-line comment here. This is a query for this class for whatever. You see, can you enter the next line? You do whatever you want to do. Another line. So I can come here again as okay. This time I want to select, this from orders. Now what I will do, let me just comment this one out, single line comment. Then let me just run everything. I see I run everything, there's no error, because when the system is running this, it comes here single line comment, this is a multi-line comment, they go straight to this place. But if I make mistake here now, for instance, then it can't do anything, error. So this one must be here. Remember, it is / in between you put what? Asterisk, then you put whatever you want to put in between. Hope you understand this. Thank you for viewing. In the layman's term, explain what where does. We should explain what where does. What is the work of where? Where is used for filter. What are you filtering? You are filtering what? records. For example, if I have some stones, some are like this, some are like this, some are like this. These are set of stones, all of them. Then I want to filter some of these stones. As at this point, no filtering. But here now, I want to filter by putting my word filter here. Assume this is my filter. All of them have to pass through. What am I telling this filter? I say I only want those that are plus to pass through this filter. So what will happen now is, how many plus do we have here? We only have 2 plus. So this one will pass through here. This one will pass through. That means they have to pass through this filter. Only these 2 will succeed. This is what? Where. We apply where here. Where. So this filter now is our where. This is our where. Okay. If you don't understand that, what if I say select all humans, okay, from this world? This is everybody. Now I want only the ladies to pass through, so I will now apply filter here now. Say where all humans is equals to ladies. So means only the ladies will pass through here now. My output today will be full of what? Be full of ladies. Ladies. And no man will pass through. Only female will pass through this place. This is also filtering. So with where we can do many things. We can use where with, put to, where and greater than, where and less than equals to, greater than equals to, where and like, where and or, where and between, where and hard, and so many other clauses. In this section, we are going to treat all of them. So let's go straight to looking at each of the instances with challenges. Thank you for viewing. Your sales manager had asked you to send him the list of all customers. Having done that, he asked you to go back and separate the UK customers from the list. The results should come with a separate column describing each row with "This is a UK customer." Let's first of all see all the customers. These are all the customers that you sent to him, but he said what? You should go and separate the UK customers. That it doesn't want all the customer to be included. All this one, country, UK. So what you're going to do now is say, okay, where country is equals to UK. You see now that the result has reduced because we filter. Before now, how many results do we have? We have 93 outputs. But when we put the filter, we now have 7 outputs. And if you check the country now, it's only the UKs that are applied. So this is the place we are filtering. This one we pick everybody. Everybody. Then we filter with this, where country is equals to this. So you can filter with anything, whatever you are asked to fetch out. You can even filter with company name, contact name, any of the column. You need to give the specific value. But this question says what? We should also include that this is UK customer on the list. So if I do something like this now, I should be able to say this is a UK customer. So that's what they want from us. So at the end, you will see such here. This is a UK customer. But sometimes you might be asked to only bring what? The company name instead of all the column. Company name, contact name, maybe address. So you can see we now have what? The company name, the contact name, the address. We see what? This is what? UK customer. Sometimes you can decide to put the UK customer first. This is UK customer first before any other column, so that it will be easier for your manager to understand. First row is, this is UK customer, this, and this. Hope this was your result. Let's move straight to the next challenge. Which of the customers has grill as ID? Simply select all customers where customer ID is equals to grill. Great Lake Food, is that what? Customer. The employee ID Cs belongs to which of the employees? You can see Cs is here. There is no quotation mark because this is not a string. It's an integer. So there's no need for what? Double quote or single quote. That is the purpose of this challenge. And if you check, that employee is Michael. Hope this was also your solution. Let's move straight to the next challenge. What is the name of the product whose unit price is 21.35? We are looking for the product name, measure the unit price from product where unit price is equals to what? 21.35. This is the name. That is the product name. Hope this was also your solution. Let's move straight to the next challenge. The MD/CEO wants to have a meeting with all the sales representatives. Help get their full details. If you move this now, we know that where to get such information is under title. So we say where title is sales representative. So you can see now, this is what they are looking for, all the sales representative. Hope this was also your solution. Let's move straight to the next challenge. You need to call all the customers except those from Spain. Get their names and phone numbers. This is the first thing I will do. So I will now know what is used for their name. What is used is company name. I also want to know what is title of the phone numbers. Phone. So I also need their phone. Then from this, so where country is not equal to Spain. Please look at this. This doesn't matter actually. I just put the capital letter. It depends on you. This is what is called not. Not. This is not in MySQL. This means Spain. Why this one means not Spain. If I put like this now, you will see all these are customers that are not what? From Spain. or all customer except Spain. Okay, to confirm this, let me remove this. I put this. These are Spain customer. So what I will do now, let me also put the country here for you to confirm. You see, these are Spain customers. So we don't want Spain customer. Put non-Spain. Country has changed. No single Spain is here. This is what the challenge is talking about. We can also do something by doing like this. The same thing. This or this means what? Non-Spain. Okay? Because if it is not equal to, definitely is greater than or less than. Okay? The opposite of both greater than and less than is equal to. So this is equal to, meaning equals to Spain. The opposite is either less than or what? Greater than. It's the same thing with this. Hope this was also your solution. Let's move straight to the next challenge. What are the products supplied by a supplier with ID number 12? That information will come from products table. But we have the supplier ID, which is 12. So let's see all the products. These are the products. So you can see the ID is common. It means that what? These 5 products. Hope this was also your solution. Let's move straight to the next challenge. Due to the current ongoing investigation on the supplier with ID number 28, kindly give us the list of the rest suppliers for urgent notification. There are 3 ways to do this. So select from suppliers where supplier ID is not equals to 28, because we don't want this guy. Every other person will be given to us except the one with what? 28. You can see this 26, 27, 29. 28 was jumped. But we will say equals to 28 now, which we don't need. You have only 28. Okay. The other way to do it is simply say not equals to 28. Same. You see? The last method you can use to say where not supplier ID equals to 28. 3 methods achieve what? The same result. Okay. Remember, if you say supplier equals to 28, we have this. Not, we have the remaining ones, the opposite. Hope these were also your solutions. Let's go straight to the next challenge. Find all products with unit price greater than 20. All products with unit price greater than 20. If you want to do this, simply select from products where unit price is greater than 20. Look at them. All these prices are all greater than 20. To make it easy to analyze, see what? Order by unit price ascending. See from 21 now, which is more than 20, to this value. Hope this was also your solution. Let's go straight to the next challenge. Return the details of products with price less than 50. Unit price is less than 50. So let me do order by unit price descending. So This is less than 50 to the smallest. Hope this was also your solution. Let's go straight to the next challenge. As we need to restock our warehouse, find the products that have unit in stock less than 10. Give only the product names and the available stock. All you have to do is to go straight to say select, product name, unit in stock, from products, where unit in stock is less than 10. Units in stock. So these are the product. This one is 0 in stock. This is 6. This is 2. So we need to restock all these products. We need to call the supplier that we are running out of these stocks. Hope this was also your solution. Let's go straight to the next challenge. Our company is trying to meet the standard minimum wages and wish not to pay any employee less than 2,000. Kindly return the details of employees who earn below 2,000. As you can see, these are the salary and they are less than 2,000. So we need to increase this guy's salary. Thank you. Hope this was your solution. Let's move straight to the next challenge. Our company is planning to send gifts to customers who have spent 10,000 and above at once, patronizing us. Help get the order IDs and line total, which is unit price multiplied by quantity as amount spent. We also want to get the line total. And line total is unit price multiplied by what quantity. And we are going to call this one amount spent. And I've told you can either put as here or you decide to remove it. It depends on you. Let's just put it. Then we are going to get this information from other details. Okay. But we want this greater than or equals to 10,000 because we want spend 10,000 and above. So let's just order by. So all this amount are more than what? 10,000 and above. Nobody spent exactly 10,000. If there was anybody, we have it. These are the order ID. From here now, we know that we are going to deal with how many orders? 1, 2, 3, 4, 5, 6 orders. We are going to prepare gift for the customer that placed these orders. Okay. And one thing you should know too is what I've decided to say, instead of say using this, I can use this guy in his place. The same thing. Because it's representing it now. Okay. Hope this was also your solution. Let's go straight to the next challenge. In the products table, unit stock feed contains the correct inventory of products. If the unit in stock value for each product is less than the order label value, your company asks the supplier involved to supply that product. Help get the list of products that need to be supplied. So let's check the products table first. What the challenge is saying is product unit is stock and what? Reorder value. If the unit is stock is less than this, that product needs to be what? Reordered. So let's see. All we have to do to say select where unit in stock, that is a column, is less than what is in the other column, that is other level. Let's order by unit in stock. So all this product needs to be what? Reordered. Hope this was also your solution. Let's go straight to the next challenge. Some of our customers from San Francisco have been affected by flood. We want a list of our customers in San Francisco, USA for urgent assistance. How are we going to do this now? We simply say so just what customer, this country is US and the city is San Francisco. Please, you have to do it like this. We know if you go straight to San Francisco, you will still have the same result. But this is not proper. Because there are some times we have like San Francisco as a city in another country. Maybe in a remote country. And you have a customer there. So that's why you have to be specific that this person is in USA and the city where he lives in USA or where they do business in USA is in San Francisco. You have to be very specific. For this to return a value, these two must be what? True. Because we are using AND. It means this one must be true. This one must also be true for you to have it return. If one is not true, you will have what? Error, or you will not have any output. Assume I put this one here now. One is not true, but one is true. But if we put all here now, for instance, this all, either of them, if either of them is correct, for instance, if I go to this place now, these are all USA because this one is true for USA. See, all of them are USA. It's okay. Just want to be true. Even though if this one, the city is not true. Like this is city is Eugene, this Walla Walla, this Landa, they are not true for this theta. But because one is true and it is all, is okay. But if you use AND, both of them must be true for you to have what? An output for this particular theta. This is what you must put at the back of your mind. So hope this was also your solution. Let's move straight to the next challenge. Your manager wants to have the details of customers from Mexico with contact title owner. Write a query to return their details. You simply select all from customers, where first the country first is equals to Mexico, and the contact title must be owner. So these two must be true before you can be part of the result. If you drop it now, you find that the contact title is owner, and the country is Mexico. Okay. If we remove this contact title, you see that we have other customer from Mexico whose contact title are not owner. Like this one, say what? Marketing manager, sales representative. Because we are filtering every other thing out, we have to put this one to make sure that what we are getting, they are also the owner of the business. Hope this was also your solution. Let's go straight to the next challenge. Send the list of customers who are neither from USA nor the UK to your manager. To do this, is select all from customers where not countries equals to USA, and remember there are two. The two must be for fee. And not country equals to UK. This is it. As you can see, if you go straight to the country column, you see there's no US here. There's no what? UK. These are customers from outside these countries. If you use all, that means each row will be, okay, let me show you. See, this is UK, not USA. Of course, this is not USA or not UK. Though this one is not good for this, but it's good for this. One need to be okay for it, for the system to return result. See, this one is okay. Therefore, it will return this result because you are using all. If you go further now, you will see another UK. Let's check for USA. This is USA. Why? We know that it must not be USA. Okay. Or not UK. Okay. It's not UK. Then I come. So that's why you use and. Therefore, if you use add now, all the UK and US disappear because the two must be true for you to be here. So for the and, the two leg must be true for the value to be returned. For all, only one is just needed to return it. If you wanted, you would have done something like this. Just put what? Not equal to here. Also put it like this. Not equal to. You still have the same solution. There is no US and UK here. Or you put something like this. You are still correct. For not. If you go back again, no UK, no US. Hope this was your solution. Let's move straight to the next challenge. The government has announced a new sanction on Argentina and Venezuela. We are asked not to sell our products to them. Kindly show the details of this customer for urgent notification. To do this, simply select from customers, I'll be using different way to arrange my codes. Before now, you see I put this one here. Sometimes I put it here. Sometimes I use small letter, capital letter. So it depends on your style because my SQL is very flexible. So this one select all the customer from here, but this one is filtering them to Brazil or Venezuela. All is the best thing here. We cannot use and. Admits that the customer must have both Brazil and Venezuela. No. When one is true, that's what we want. We just want only one leg to be true. If you are Brazil, okay. If you are Venezuela, okay. Not about both. Either of them, we are okay. So we want to what? Know this customer. If you go straight to the country, you find that what? It's all the Brazil are selected. The Venezuela are not selected because we made a mistake in here. So let's go back and see. Find that now Venezuela is included now in our output. Hope this was also your solution. Let's go straight to the next challenge. Help get the details of suppliers whose suppliers IDs are from 20 to 25. To do this, just select from where supplier ID is between 20 and 25. Get the list. Okay, from 20 to 25. So between these two, from 20 to 25, because between, we start with that number, not after the number. Our hand in the other number. So it's between 20 and 25. That is, this number and this number are inclusive and the number in between them. You can see 20 and 25 are inclusive, and all the numbers in between them are also inclusive. Hope this is also your solution. Let's go straight to the next challenge. Help get the details of suppliers whose suppliers ID are above 22 or below 10. Is less than 10 or supplier ID is greater than 22. And you check here now if all these ones are less than 10 and the remaining ones are what? Above 22. Hope this was also your solution. Let's go straight to the next challenge.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.